Yes, we back for another session. Let's go. What you guys saying? Let's go. Yo, Ethan. Yo, Gang. What are you saying? How's live? How's revision going? Paper 2 is gonna be light work. For real. Let me get my tuna smoothie ready. Yo, hands up. Paper 1 was easy. I can't lie to you guys. I did have a look at paper 1, obviously, to be able to do this. And paper 1 at Excel was quite easy. I can't lie. Dion, tuna smoothie is not good for me. It's good enough, my friend. It's good enough. So yeah, guys, we can only assume that paper 2 is going to be a lot harder. There was not that much calculus in paper 1, so yeah, we will see. But yeah, I predict that paper 2 is going to be a little bit harder than paper 1. So yo. Little on quality. I got cooked in paper 1. Don't worry, hopefully this will help you out. Yati, paper 1 was disgusting. Well, hopefully we can recover ourselves. So the way I'm going to structure today, guys, is I've basically gone through paper 1. I've identified topics that didn't come up. So I'm going to go through some key questions today on that. But then at the end, I've tried to leave a bit of time for us to basically go through questions of your choice. So I'll give you guys a form that you can all click onto and submit which questions you want or what topic you want to do, and then I'll go through it. So that's the way I'll structure that one, just to give you guys a bit of opportunity to choose. But also, guys, in Cram Course 1, make sure you guys check out some of the questions on that, because they could still come up. For example, the greatest question that was ever asked. You guys need to go through that again, all right? I'm not going to do it again. So yeah, guys, I'd appreciate if you hit the like button for the Lung Gang. There's over 1,000 of you here trying to raise the grade boundaries. So yeah, it helps me out a lot. Thank you. Dark Lord, what's the greatest question? My friend, you have to go on Cram Course 1. Thank you for the likes, guys. So if you don't know already, my name's Neil Trivedi. You've probably seen this 100 times, but I have to do it, man. I'm a fully qualified maths teacher, over 9 years of teaching experience, and they're my geeky maths grades, innit? So I guess you can say I'm a bit of a maths nerd, and it's time for me to make sure you guys become just as much of a maths nerd as I am, innit? Okay, calm. Yo, Melonhead, we saying? No, today is just pure, because it's tailoring to the EDEXCEL spec. Because I'm only one guy, guys. I can only do one spec at a time. The first Cram is kind of a free-for-all, but second one I can't, unfortunately, as one man go through everything, right? So yeah, if, guys, this will benefit any other of your mates. Make sure you share it with them. Neil, thoughts on the edits people making on me? DW, I haven't actually, I've only seen one. Have I seen one? Only someone just posting me and saying South Asians during exam season, and it's just like me with a dark filter or something. So guys, it is subscribe only mode. If you are watching and you can't comment, it means you just need to subscribe, then refresh, and you can start chatting straight away. See a gatekeeping this live. That's crazy. Hey, your pen, your violin. Yeah, guys, as I said, I'd appreciate if you hit the like button and turn on notifications. I am going to be uploading some crazy applied questions over the next week, so you don't want to miss it. So something that didn't come up really, there was that prime, what was it, something like 5M plus 1, if you guys remember. Something like that. Do you guys remember in paper 1, there was that 5M thing? I can't remember. Thirst traps go hard. What are you talking about? I didn't do a thirst trap. I would never do something like that. Okay, so you guys remember that. But there wasn't like an explicit proof on contradiction, okay? So let's just make sure we know how to do a proof by contradiction, okay? So the first proof by contradiction, and I did a few in the first stream, so make sure you check out the other one I did. I think it was primes and primes and that. Prove by contradiction that if m squared is divisible by 2, then m is divisible by 2. So what is the assumption that we make here? Yo, Ish. Yo, Nimra. Shout out to my boy Nightbot. What is the opposite am? Yo, Nan. What are you saying? Nice, Jack. It's an if this, then that question. So, yeah. Guys, these are a very typical form of contradiction. It's an if this, yeah, if this, then that. The way you do the negation is you keep this, yeah, you keep this, and you change the that, yeah? So I'm saying if this, then that, okay? So how do we change this statement? What would you say? So we're going to say, assume, little on quality, my bedtime is 9 p.m. That's good. I shouldn't be overrunning by after 9. But AK, what do you mean by not divisible? You can't just say not divisible. If you're not divisible by 2, what does that mean about the number? Guys, come on, mate. It's not looking good. Thanks, Ama. It means it's odd. Okay, so assume that if m squared is divisible by 2, then m is odd. Good old fellow. So what are we going to let then? Come on, mate. Sham is here. You're not even doing the right question, little bro. Fork's good. So we're going to let m be an odd number. 2k plus or minus 1. It's up to you. I'll just do 2k plus 1. And then we're going to square it. All right. M squared is 2k plus 1 squared. Which you guys hopefully know how to do this by now. Now, with that statement, how can we be very clear that that is not divisible by 2? So you have to be very clear that this is not divisible by 2. How do we do that? 4k squared. Yeah. Making sure you guys are awake in it. Factorize out 2. So obviously from the first 2 terms, guys, you can factorize out 4. But for even, really we need to show it's a multiple of 2. That's mistakes. Nah, don't make me do a tally, yeah? So I have 2 lots of 2k squared plus 2k plus 1. So this is a multiple of 2 plus 1. So this is an even plus 1, which is odd. This is a contradiction, which contradicts... Yo, Hamza, we sim. Which contradicts our statement that m squared is even or divisible by 2. Yeah. Ayo, guys, let's get some W's in the chat for Hamza, because he was in our stream for 5 to 6 hours last stream, and dude's just chilling there, man. Like, just making sure you guys are learning. He's one of the OG Lund Gang members, guys. He was in your position last year or year before, and yeah, he's vibing, man. So you guys can ask Hamza as well if you have any questions, my guy. Go to bed, man. Hey, yo, Hamza doesn't go to sleep. Therefore, we've got m is divisible by 2. Okay, calm. Now, usually they don't ask you to do part A. They allow you to just assume it, okay? Part B is we need to use part A and part B. So let's assume root 2 is rational. Lund gang. Now, you guys need to tell me, what do we mean by a rational number? Hamza unemployed for real. Abdul, don't be a hater, man. Hamza actually gets paid by my headspace. Bro has made his money back from investing into my headspace. What a legend. That's how you game the system, man. This is my job. Trust me, Hamza. Bro is bargain. Okay, so here we make it P over Q. So a rational number is a number that can be represented as a fraction where the numerator and denominator are integers. However, what do we need to say? Kayan, good. The denominator can't equal 0. So you can use A and B if you want. So we're going to say where P, Q are elements of the integers. You don't have to write like this. You can write in English. Yeah. We need to say that Q cannot be 0. And we need to say P and Q are co-prime. P and Q are co-prime. Okay. You could also say the GCD is 1, meaning the greatest common divisor is 1, which just means that it's in its simplest form. Hey, Irina. Luke, is this year with my English language exam? We're basically just doing English now. Next thing we're going to do is we're going to square both sides. Co-prime just means it's in its simplest form. So when we square that, we have P squared over Q squared. Multiply through by Q squared. The proof is very intuitive, right? So what does this imply? Can you say no HCF? Ali, you could say the HCF is 1. Okay, so you could say, instead of saying our co-prime, you could say the highest common factor of both P and Q is 1. Good, so if P squared is a multiple of 2, it must mean P squared is even. Which by part A, that means P is even. Okay, so if P is even, we're going to let P equal 2K and just plug it in there. Okay. The rest of it becomes obvious, right? I wish we could say proof by obviousness. You guys should have practiced this proof so many times. So this implies Q squared is, Q squared is even. Which implies Q is even. Which is a contradiction, right? So if Q is even and P is even, it means that their greatest common divisor is 2. And that means that they're not co-prime. Okay? Ayo, Hassan, what is this? So this contradicts. So we could say P and Q, both even, contradicts our assumption that P and Q are co-prime. Therefore, root 2 is irrational. Can't. All right. Those of you asking me what am I doing today, I've got a workbook in the description. Even Nightbot's putting it in the chat for you guys. Okay. Yeah, guys, this Z is the set notation for integers. Okay, so rational numbers would be Q. What else is there? Natural numbers. N. Complex numbers you don't really need to worry about. R for the real numbers. Guys, you've seen all these before, man. Okay. Solving with modulus functions didn't come up. I did a very good question on solving with modulus functions. I don't know if you guys remember. I don't remember exactly what it looked like, but it was something like this. Do you guys remember that? I did a really important question like this. I think it might be minus B or something. So take a shot. Guys, go back to Cram 1 to see that question. I'll probably forget here and there if I've done it, but I'll try to remember if I've done topics in Cram Course 1, so you guys can go back and check it. Okay, I love to see it. Some of you guys remember that from the first one. That's good stuff. That's good stuff. Okay, on the same diagram, sketch the graphs of y equals modulus x squared minus 6x plus 5 and y equals x minus 3. Okay, now y equals x minus 3 is really easy. To do the modulus quadratic, what would you guys be doing first? Sam, where did I get these gloves from? Lidl, man. Come on. Cindy, good. The roots. So x squared minus 6x plus 5 is 0. Okay. Then we need to factorize. Most likely, guys, in the... Use the numworks. Most likely in the exam, guys. Oh, the number of viewers is 2024. Oh, no way. It's 2025 now. They would say solutions strictly off graphical, whatever, won't be allowed. Okay. So that's not going to work. Nice try, though. X is 5. X is uno. Calculator is short for calc, by the way. So it looks... We could do like a really basic sketch for now. Like it looks something like this, right? So we have 5 and 1. Where does it cross the y-axis? Trust me, Hassan. I do have my CG50 here. It even has my name on it, like a good boy. Casio actually gave it to me for free. I've got the unk and the baby. 5. Yeah, so I've done the 5 and the one the wrong way around, but it should be this way. So it looks something like that. But when the modulus run the whole thing, good boy. What does that do? What transformation is that? The Mohammed calculator. I don't think that's this one. That's the one I have at home. Shout out to my boy Mohammed Hassan though. I've still got your calculator. Okay, it doesn't actually look like a V, this one. Liam, good. It's a reflection. Farhad, good. Whatever's underneath the x-axis gets reflected upwards. Okay. So a modulus around the whole thing means anything underneath the x-axis gets reflected up. Okay. Right. Now if I go, I'll do it down here. That's a W. So you're going to look something like this. Okay. Now, when we draw x minus 3, so it crosses the y-axis at minus 3. Where does it cross the x-axis? It's 3, isn't it? Okay, so... Well, that'll be right in the middle, to be fair. Beautiful. Look at that. Now, respect it. Okay, so that's sketched. Blooming, what is reflected in the y-axis? So, guys, if it was to be reflected in the y-axis, it would look like this. It would look something like that. That would be if it looked like this. Okay. Now, if I was being really mean, I don't actually need to do this. I've actually given my students questions like this before, and they had to recognize that this is a reflection in the y-axis, because squaring a modulus doesn't make a difference, because the modulus makes it positive anyway, and squaring makes it positive. So you don't actually need to have the modulus there. So be careful, guys, when you see something like that. Okay. Right. Hence solve this, well, find where they equal each other. Now, if you remember, what do we have to do first? To find these 2 points of intersection. CS WD-40 on the chair. It's my studio chair, man. It's not even at home. It's the building gives it to me. So we equate them, but what do we need to... When we... Yo, Fresh Prince. Nimrod. Okay, so we need to write the equations of certain graphs. So this is obviously y equals x minus 3. Now, this part of the graph, is that the positive or negative modulus? Is that the positive or negative modulus? It's the positive, right? Because that wasn't the reflected. Okay, so that's just y equals x squared minus 6x plus 5. And it's this one that is the reflected, where we make it negative. That'll be minus x squared plus 6x minus 5, right? So we have to solve it with both. And this is why we need to do the sketch. Because we can see that there are 2 specific solutions there. Not all of them. So let's do minus x squared plus 6x minus 5 equals x minus 3. And then x squared minus 6x plus 5 is x minus 3. Let's just do the positive one first. X squared, what is that? Minus 7x. 7x plus 8. That factorizes, right? 8 on 1? No. Don't think that works. I don't think that factorizes. So we're going to have to opt for the formula, right? Yeah, let's just use the formula. That's a tricky one, mate. I feel like that, what do you mean Neil does mistakes? I saw it before you guys, man. Hey, yo, nah, you guys are bugging. Yeah, Neil nearly makes mistakes. Hey, yo, what are the 2 solutions, man? I'm not typing that whole thing in. Well, Shez, there is the other one, mate. Nimra 1.43, and ZZ 3.40. Wait, hold on. Why are we getting different answers? Ayo, nah. Some of you guys are cooked, man. How do you not type this in the calculator properly? Don't worry. I'll move like Thanos. I'll do it myself. 1 minus 7. 8. 5.56. Ayo, who said 4.3 though? I'm going to need to do a VAR check on that one. 4.44. What was it? 5.56. Okay. There we go. Yeah, 5.56. Cool. Which one do we want there? Hey, where's the tuna smoothies here, little bro? Don't worry. Have some of that later. 5.56, good. And this again, guys, where the diagram is super important. You can see the solution we want there is bigger. So x has to be bigger than 5. Therefore, x is 5.56. Okay. With this one, we have to bring that to that side. So we get x squared. Minus 5x. What is that? Plus 2? According to my calculations, right? Jalebi. And then formula again, yeah. X is 5 plus or minus root b squared minus 4 a 2 over 2a. Okay, can we round it properly, please? Kauthar said 0.43. I'm putting them on the spot. Is it 4.3 or 4.4? Hey, yo, nah, guys. I can't believe you're making me check this. Typo. Hey, yo, nah, you guys can't be saying typo for everything, man. 4.44. Okay, cool. So here we know that root here is between 3 and 4, right? So x is between 3 and 4. Therefore, x is approximately 0.44. There we go. So yeah, that would be regarded as a tough question, but I would say this one from Cram 1, guys, is more tough. Okay, so make sure you go back to Cram 1 to look at that one. Here's a great question. I'm going to kind of fuse A-level maths with a bit of real life, okay? I'm going to show you guys how something that's really important you do, yeah? Is I'm bugging. What? Go back. What did I do wrong? Oh. Yeah, thanks. How many of you guys have heard of an ISA before? Uncle. How many of you guys heard about an ISA before? It's really important you guys learn about ISAs, okay? I'm gonna fuse A-level maths with a bit of knowledge about real life, okay? However, shout out Rachel Reeves. She's gonna be potentially changing the rules on ISAs, okay? So the question says, I decide to invest into a stocks and shares ISA. I can afford to invest £12,000 per year over the next 25 years. An average medium to risk, high risk portfolio can expect to make 10% interest per year over this duration. How much will I have in my ISA after 25 years? So, an ISA, guys, is a scheme in the UK where you can invest your money or put your money into an account, and any money you make, the government can't touch it, okay? So, that's basically what this is. And the ISA allowance in England is £20,000 per year. So you guys could put money up to £20,000 into an account, and any money you make, you don't get taxed, which is a really important thing. However, apparently Rachel Reeves wants to decrease it. So if you guys can abuse this allowance, which is super generous, I would say do it. And I'm going to show you guys how much you can potentially have if you take advantage of this take advantage of this scheme. So there are different types of ISAs, guys. This is not Neil Does Finance, but there's a stocks and shares ISA where you can invest into literally stocks and shares, okay? So I'm going to put £12,000 every single year for 25 years. And I expect to make 10% on my money every single year, okay? How much do we have after 25 years? Now, it looks like a geometric sequence, but it not necessarily is a geometric sequence. Let me show you why. With these kind of worded questions, guys, that they can ask you, obviously, for geometric sequences or arithmetic sequences, is you need to find a pattern, okay? So all of this, guys, you need to find a pattern. And as Hamza's correctly said, because we are investing £12,000 per year, we're adding £12,000 every single year. So we're not just multiplying by 1.1, which is the 10% interest. We're also adding 12,000. So it's a combination, okay? So my advice to you is to look at the beginning of year one and end of year one and go about that trend. Beginning of year two, end of year two, etc. Now, the beginning of year one, we put in 12K, right? Without working it out, how would you work out end of year one? How would you work out end of year one? Nathan, it's a lot more than 130K. Darshan, it's a lot more than 430 bags. Okay, good. So it's 12K times 1.1. Okay, don't work it out because we need to find a pattern. What would the beginning of year two be then? Without working it out. Sunli, good. So it's going to be end of year one plus another 12,000. All right. So it's end of year one plus another 12K. Okay. End of year two, what would that look like? How would you represent that? So we had our money at the end of year one, then we're adding another £12,000, right? Is on good. So it's the... Okay, no, wait, that was the one from before. Nimra, is it just that though? So Sophia, yeah, it's beginning of year two times 1.1. But we need to utilize the distributive property here. We have to multiply this 12,000 by 1.1. And then this previous investment becomes 1.1 squared. Okay. Now we're talking about after 25 years. So we're talking about end of year 25. Okay. Skipping the beginning here. So this is end of year 25. What would end of year 3 look like? So here I'll be able to see if you've actually seen the pattern. Ben Gimley, nearly. That'll be for the 25th one. So Ellie, it'll be plus that at the end, right? So it's end of year 2. But we're going to have an extra term that is cubed. Okay, good, Liam. So you can see with end of year 1, it's power 1. End of year 2, it ends in power 2. So end of year 3 is going to be end of year 2 plus the cubic term. Okay, nice, Zach. Okay. Which then means we can see what end of year 25 will look like. Okay. End of year 25 will be this first term. I'm just going to write this. I can't bother to write times. Plus all the way to 1.1 to the power of 25. Okay. But this sum, is that an arithmetic or geometric? So if you're doing 12,000 times 1.1, maybe I'll write another term in the middle. 12,000, 1.1 squared plus dot dot dot. So this is geometric, okay? So this final sum, guys, is geometric because we are just multiplying by 1.1 to go from term to term, okay? So let me just put it side by side. So the end sum is geometric, but here it was like a combination of both. Now, to make life easier in terms of writing the calculation in the calculator, I recommend that you factorize out 12k. So it'll be 1.1 plus 1.1 squared plus dot 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 1.1 to the power of 25. So A is 1.1, R is 1.1. The number of terms is 25 terms. So we are doing 12,000. Shout out Nightbot. What is it? 1 minus R to the power of N all over 1. Sorry, 12,000 times 1.1, sorry. Because 12,000 lots of, right? 1 minus R. Okay, so what does that give you? Abbas, no, don't worry, this isn't me, man. It's just hypothetical, man. The first term is 1.1. Why is A 1.1? You can see. Come on, guys. Come on. Then we have that 12,000 on the outside. So it's basically like this. 12, 1, 2, 3 times. And then it looks like this. So A is 1.1. 1 minus R to the power of 25. All over 1 minus 1.1. And there you go, guys. 12,98181.19. That's a lot of money. By putting in by investing 12k. That's a lot, man. It's a lot of money. I definitely recommend. Definitely recommend. Okay. Not enough for this month's rent, can't. Especially in London. Which is kind of crazy. Hunk secretly shared his ISA. I've not been investing 25 years. Imagine if it was 20k. If you max out your ISA, guys. That's it. That's how much you would have. That's over 2 milli. And the taxman can't touch it. Taxman cannot touch that money. It's pretty decent. It's pretty decent. Ishal, why is A not 12k? Because I've factorized it out. Jalebi, Unk, hire me. Hire you for what, little bro? Cozzy Liz, Joshan. Yeah, I know. It's tough times out there. Even if you put a little bit. You guys are what? 15. So, like, you eventually be able to invest. You have to be 18 to do stocks and shares ISA. But, you know, when you guys get to 18, you guys can start doing this, all right? Okay, good stuff, good stuff. You guys just about upgraded from Peppa Pig to Coco Melon. It's looking good. Now, we actually did a question very similar. If you guys remember, it was like, do you guys remember I did like 3N and M plus 1 or something like that? Of 7R plus 2. I don't know how I'm remembering these questions, but you know how it is. Do you guys remember this one from Cram 1? Okay, make sure you guys go back and rewatch that. Okay, it's a very good question. We're going to use the idea here. All right. So here we have to find the value of the sum from R is 10 to 50 of R plus 3 over 6. Okay. Now, with these kind of questions, guys, we don't need to use this kind of concept, like the algebraic stuff. But still go and check out when I did it in the previous one. This one, we can just consider how many terms there are. But what type of sequence is this? Is it arithmetic or is it geometric? Yo, Pramit. Zakia, I didn't burp. What do you mean? It's arithmetic. Good. Because there's no powers here. Okay. Now, if you see a question like this, I would recommend you rewrite it slightly. Because then you can see better what D is. So we'd write it as 1/6 R. We'd split the fraction plus 3 over 6 is a half. So from there, you can always identify what D is. What is D here? Yeah, Ed Pierce, for real. Celine, good. Tash. So remember, it's always the coefficient of R. So guys, the coefficient of R tells you what the sequence is going up by, because 1/6 R means the 1/6 times tables, okay? So it's always the coefficient. How would you work out A? Yeah, SR. A, man, not quite. So A is not a half. Buin, good. We need to substitute the first term being 10. Okay, so remember guys, it's saying this sum, or this sequence, from the 10th term to the 50th term. So we can just treat the first term as being the 10th term now, okay? What is that? 10 over 6 plus a half, what is that? Lay said 13 over 6. How many terms are there going from the 10th to the 50th term? How many terms are there? Nice, Hamza. Dropkin, I see you. Love to see it, Mike. Guys, it is not 40. It is not 40. Clipped. Clipped. It's not looking good. Ayo, nah, you guys can't be checking other people's answers. Yo. So, if you say 40 and you do 50 minus 10, why is that wrong? Why is that wrong? What are you getting rid of if you just do 50 minus 10? Yeah, good. Guys, when you do 50 minus 10, you are subtracting the 10th term, but we want to include the 10th term. So if I give you guys an easier example, I always say, look, if you ever stuck in an exam, do an easier example like 5 to 10. Okay? So you want to sum the 5th term to the 10th term. So you have 5. You want to do the 5th term. 6, 7, 8, 9, 10. That's 6 terms you're trying to add there. Okay? So you do the top minus the bottom. So you do 10 minus 5 is 5, but then you need to add 1. Okay? So I need you guys to remember that. It is the top minus the bottom plus 1. So yes, it is 41 terms. Okay? So another way you guys could do this if you want to is you could use the alternative formula, which is Sn A plus L. And then you could find the last term by subbing in 50. It's up to you. You could try it. You'll get the same answer. But most students would just use the generic n over 2. So n over 2, 2a plus n minus 1 d. Okay. What does that give us? Yakuba said 451 over 2. Irina said the same. Yo, Sakuna, what's up? Clause, could you use the further maths method half n plus 1? Well, that's summing integers, right? So you'd have to manipulate it. That's not a sum of an arithmetic. That is the sum of r, right? Slightly different. Okay, so there we go. We got that. Okay, next one. So that's a geometric sequence because it's a power, right? Now, with the geometric sequence in this form, what is the common ratio? Roha, good question. What if it starts from 0? So if it started from 0 like this to like 50, what you would do of some sequence is you would sub in 0. You would do u0 plus the sum from r equals 1 to 50. So you'd rewrite it like this. That's a good question, guys. So if it does start from 0, they do that. It's quite cheeky of them if they do that. But yeah, you sub in the 0th term and you take it out. Okay? And then, yeah, you sum from 1 to 50. And then you can just take n to be 50. Okay? So here, what have we got? We've got the sum. Yo, leaps. Aiden, for real. R equals 3 to 21. Of 5 times minus 2 to the r. So you guys are right. All right? It is the base number that is the common ratio. Because we know that un is of this form, so r is always the base. Okay. Can you tell me what the first term would be here? Leon, yo. Boo insane. 5? 5? Now, where you guys getting 5 from? Hey, yo, don't do this to me, guys. Eli saying minus 40. Okay, so here, guys, we have to sub in the first term, which is 3 here. So that's 5 times minus 2 cubed, which is minus 40. Okay. Okay, let's make sure we get this right, guys. What is the M? How many terms are there? Yeah, shush, I mentioned that before. Karunga said 19. Rory and Deshaun said the same. Okay, good. So we're doing the top minus the bottom plus 1. Okay. 21 minus 3 plus 1 is 19. Alright, so this sum 19 terms. It's what? A? 1 minus r to the n all over 1 minus r. What does that give you? Poser with the talk internet, Mike. Minus 40, 1 minus 2 to the 19. 1 plus 2. Yo. Minus 6990520. Yeah. And obviously with something like this, guys, you can obviously check on your calculator by just doing this and just type it in. Yeah, and then you'll see. Okay, cool. Here's a great question. It says a sequence is given by Tn plus 1 equals a plus b Tn, where a and b are non-zero constants. It is given that T3 is 320, T4 is 240, T5 is 200. Determine the value of A and B. Okay, how would you guys start this problem? I mean, I believe in you, man. Cindy, we probably will do simultaneous equations. Sub what in? Can you guys tell me a formula in terms of T that relates this and all of these potentially before we sub things in? Harris, T5 minus T4 equals T4 minus T3. Okay, so you have to be careful there. So what you've assumed, Harris, is that this is a arithmetic sequence. Guys, is this an arithmetic sequence? Yes or no? Is it arithmetic? Abdul saying no. Clause, no. Okay, so the answer is no. What would the form of a arithmetic be in recurrence relation form? It's not a geometric either. What would it look like if it was arithmetic? Periodic? What's that got to do with this? Hey, yo, it's good you guys are here, man. Thanks, Alex. That is true. It's good you guys are here, man. That's a big W. You guys are learning a lot of new things today. Arithmetic sequences are in the form of un plus 1 is the previous term plus k. Okay? What about geo? What would geometric sequences be in the form of? Un plus 1 is what? Gavin, that's it. Yeah, nice one, Gav. So to find the next term, you do k lots of the previous term. So kun. Okay, so make sure you guys write this down. When you combine them, guys, like this has, it's nothing. We don't know what that is, okay? So what this is saying is to find the next term, you're doing a plus b lots of the previous term. So we can link this all up by saying, all right, to find T5, you're doing a plus b lots of the previous term, T4. To find T4, you're doing A plus B lots of the previous term, T3. And you can do it as much as you want, all right? I think this is enough in terms of what we have, right? So T5 is 200, is A plus B lots of T4, and T4 is 240, sorry, B. And then here we have T4 is 240. Arithgeogre. And then we have Ayo, nah, I forgot about this fire alarm in this place, man. Mate. I've got my headphones on, I can't even hear it, but thanks, Layla. Is that a picture of me? Ayo, what is this? Can you guys hear the fire alarm? It's not looking good, man. Too much tuna smoothie. Is A plus T3 is 320. B. Okay. I'm gonna burn. Burn, baby, burn. Disco Inferno. Okay, so now we subtract. What is that? 40 is... What's 320 minus 240? 80? B. So B is a half. Okay. And then we plug it in. Let's sub into this one, number 1. 200 is Lottie the Jug. Where am I, Unk? I'm in a building. A plus 240B is 120. So A is 80. Look at that. Now respect it. So we have TM plus 1 is A. EDEXCEL headquarters. Hey, yo. You guys don't realize, but I'm best buds with the head of EDEXCEL, innit? Maths. We're best friends out here. She's got me on LinkedIn and that. Get the paper. Shout out all you guys adding me on LinkedIn. Apart from Pramit though, I had to do the clean decline on his request. Determine the value of T6. So T6 is... So then to find T6, we're doing 80 plus a half of the previous term, which is T5. Which is 80 plus a half of T5. T5 is 200. What is that? 180? Let's go. Show clearly that T1 is 800. Now, we are going from T4 to T5 to T6. What would help us work out T1? What formula would help us work out T1? Clause, you have to work backwards. Yes. So T3, then T2. Yes. So if you guys don't know about T2, you should search it. T2 Flowers Starship Remix. You guys won't know about it, but it's an absolute tune. I'll give you flowers in the pouring rain. It's driving me insane. Banger song. What do you guys know about that tune? You guys still listening to Peppa Pig theme tune and that? Now, we don't know what T2 is, so we're going to have to use T3 to work out T2 first. In fact, on my Spotify, I think I'm going to play some garage tunes. Can you guys work out T2 for me whilst I play some garage? Let me find it. My garage playlist is so good, man. Where's T2? There it is. All right. 4A. So we got T3 is 320. No Frank Sinatra today, Adam Ski. Not today. So we have 240 is a half T2. I'll bring you flowers in the pouring rain. Also, it's Sweet Female Attitude, not T2. But T2 is another UK band. So banging. So you have 480. Drop the Spotify. Okay. So that gives you 400. Is a half tier one. Then you double it. Nice. Now, the next part is to find what the sequence converges to. So what I'm basically saying here is the sequence converges to some value L. Determine the value of L, okay? Now, as who said it? Someone did say it. Gog. Gog said iteration. It is an iteration. You could basically keep computing it as you guys are basically doing in the chat. So you have Tn plus 1 is 80 plus a half Tn. And you can start with T1 is 800 and just keep pressing equals. And you guys will find it. I'll show you guys how you do this algebraically though. So in the exam, they most likely will allow you to just do this. Yeah, look, if you keep pressing equals. Eventually you... Didn't some of you guys say 80? I get 160, but... Anyway, I'll forgive you guys for saying 80. I'm going to show you guys how you do it algebraically. Eventually, as you keep pressing equals... No one said 80, Unk. Wait. Do you know what? I'm not even going to bait people out. I'm a good guy. So, as you keep pressing equals, what ends up becoming true about these two values? Good, Rory. Truth, good. So guys, as you continue to press equals, the next term becomes the same as the previous term. So eventually, Tn plus 1 equals Tn, which equals L, which we can now substitute. Move that over. And then L is 160. So that's how you prove it. And in fact, doing it like this is much quicker than just continually pressing equals, right? All right, calma. The binomial expansion. I did a great binomial expansion question in the first cram. This is a binomial question that hasn't really come up in a while. But it's a very important one for part B and C. Part A shouldn't be too difficult. How do we do the binomial expansion on that? Sienna, I am the answer to the workbook. Haha, it's too easy, skip it. So Nimra, power minus 1. Yo, shit. Power minus a half. And Lottie, yeah, exactly. So guys, we bring up the denominator. 4 minus 9x. It'll become power minus a half. What else do we need to do here? Oh, I had skip, just teach the part B's, but you need part A, man. Young almond, good. So we need to factorize out the 4. So guys, very important we remember that for the binomial, we need to make sure that that's 1. But when we factorize out 4, Grace, exactly, we need to make sure we maintain its power. So it's 12 lots of 4 to the power minus a half. Then we divide everything by quattro, which is 3. Wait, no, 6. Lots of 1 plus n x plus n. Hey, yo, wait until the 12-hour stream next week, man. I'm gonna... Oh, I don't even know how I'm gonna tally it, but where's Pramit tallying everything, man? Plus... n minus 1, n minus 2. I'll move my calculator in a second. Calculator short for calc, by the way. Okay, we get this, yeah? Which we then can type in. 24-hour stream, Moise. Moise. So we got... Are we going to order Nando's during the 12-hour stream? Absolutely. Maybe we could do breakfast, lunch, and dinner. Now, for the rest of it, guys, the way you type it in is exactly how you see it. You just get rid of the x. So this is how I type it in. Okay. So we have minus... It's just going to be easier for me to write minus 0.5 minus 1.5 over 2 factorial. Minus 9 over 4. Minus 9 over 4 squared. Did you guys get that? Yo, Param. So I get plus 243 over 128 x squared. Then all you do, guys, you just go back and change that to cubed. You just have to remember to re-input the x. 3. Hey, Mariks. Minus 2.5. Bro, it's not minus 9x. Huh? It's not minus 9x. What are you talking about, Bossman, aka Apnage? Is it not plus? What do you mean? Where are you guys seeing plus from? It literally says minus over here. Where are you guys looking, man? Okay, don't worry. I'll contact Specsavers for you guys. $1024. Is it not plus 9x? Is it, guys? Is it not plus 9x? And now we need to expand the 6. Six times 9/8. Oh, hell no. You guys are gonna make me my brain melt today, man. 27 over 4 x. And then 6 times. Hey, oh, no, I'm using my calculator for this. I can't bother to keep swapping. 243 over 128. 729 over 64. X squared. Then we have 6 times 3645 over 1024. Yo, that's crazy. Thanks a bit. Calm. Now, this is where things get interesting. Is use your answer part A to find the binomial expansion in ascending powers of x up to and including the term in x cubed of 12 over root 4 plus 9x. How will that affect my answer? Don't worry, Melissa, it's not that bad. Cindy, all of them? Mags? Is it all just getting multiplied by -1? Nice, Ama. It alternates, okay? So, guys, it doesn't all become negative because what you're doing with this is you have basically the exact same thing. It's just the minus 9x is becoming plus 9x. So, if you look over here, these are just becoming positive, okay? So, what that's going to do is if this minus becomes plus, then that second term here is going to become negative. Yeah. But this term here, because it's squared, it doesn't matter whether it's positive or negative. It doesn't make a difference to the even powers. Which means that third term, which I don't have my calculator, this third term here, because it's cubed, if I change that to plus, it's going to change the sign over here. Yeah. So these are going to become negative. So yeah, it becomes plus minus plus minus. Okay. So we can copy the exact same answer. It's just alternating sign now. Okay. Nice. Now, part C is 12 over 4 minus 18x. Now, that looks like it's completely changed. How does that affect? Hey, your TikTok's bugging. Oh, snap. Yo, TikTok, we sin. Okay, there we go. How does it change? Niha, you're timesing by 2. All terms are doubled. Not quite. Not quite. All coefficients are not multiplied by 2. Nice, Hamza. TikTok's always bugging. Gone. Good. So, guys, you have to be very careful. The way this goes up is not just by multiplying by 2. So, because you're multiplying by powers, right? So, you have this. So, when you factorize out the 4, yeah, we still get that 6. So, we get this. So, I'm just being thorough in terms of what's going on here. So what's happening here is what you're substituting in is doubling. Okay. So we're doubling our sub. Okay. Now that's going to affect these. So you're doubling this. You're doubling this. And you're doubling this. However, the first term, yes, you're doing 9 times 2. But this you're doing 2 squared. So that squared term, you're actually multiplying by 4. And this third term, you're actually multiplying it by 8. Okay? So, what's actually happening is it's the exact same. The first term, you're multiplying it by 2. And it's also minus, right? So, actually, I'm looking at this one, guys. Plus 729 over 64. X squared. Then you're multiplying this by 4. And then the last one, you're multiplying by 8. Ayo, but Neil, drink some water, you absolute basket case. Ayo, what? Hey, I haven't drank water, to be fair. Okay. So what does that simplify to? Oh, wait, that'll be 27 over 2. X. If you just redo the expansion, will you get the marks? Yes, Mickey. But that'll be very long. Is that a metal cup, Astro? Yes, it is. Come on. I'm half Asian out here. Of course I'm going to be using a metal cup, mate. If you know, you know. 729. How many of you guys know about the pink containers? Then we got 10935 over 512 times 8. 10935 over 64 x cubed. And that's your answer. So in the exam, this would be worth 2 marks. This would be worth 1. And the first one would be like 3 probably. 3 or 4. Big question. I don't know about the blue flower plates, no. Nimra, because you're cubing it. It's 2 cubed. It's power 3, right? It's not 2 times 3. Okay, next one. Prove this. That's cosec, by the way. How would we prove that? Yeah, my cat has tuna smoothie. She doesn't really like tuna, though. She prefers chicken. That's a W. Good. It's difference of 2 squares. Nice. So, guys, when it comes to proofs, and remember, guys, I showed you a cheat method in paper 1. Make sure you guys check out the cheat method from Cram course 1. But it's always easier to be able to go from larger powers to smaller powers. Okay. And what we notice that we're taking the difference of 2 square numbers. So power 4s are square numbers. Okay. So we can do dots. We have cosec power 4 theta plus cot. Whoops. Squared, sorry. Squared theta. Cot. Squared theta. And then we'll have cosec squared theta minus cot squared theta. Now, what do you notice about one of the brackets? Trust me, Vika. Ayo, which bracket? Okay, so we have 1 plus cot squared theta is cosec squared theta. So moving the cot squared over, it's the second bracket. So this is uno. So to the first bracket, what are we doing? Saded, maths paper 3 was easy, thanks for being nice. Saded, GCSE done. Let's go. Trig identities, I wouldn't do that for this one. There's nothing to expand. Yes, Rory Balamori, we change cosec and cot into what? Serial, good. We change it to 1 over sine squared. Because look at what we're trying to get into, guys. Cos. Yeah, so we might as well change it into sine as well. Plus cot, which is cos squared over sine squared. And there you go, guys. You should be able to start seeing the answer now. Because now the denominator, we can just use our Pythag identities again. And then we're done. How many marks? At least 0. Okay, you ready for the next one? Hey, yo, Santa Claus, it's all good. Nightbot sometimes is a bit upset about things. Damn! Hey, yo. Respect to you guys raising the grey boundaries for yourself. Loon Gang for life. I'd appreciate if you guys hit the like button if you've learned something new, which I know you guys have, because so many mistakes, mate. 80. I'll never forget about the 80. Prove. Sine 2 theta is equivalent to 2 tan theta over 1 plus tan squared theta. Are we going to go for the left side or the right side? These are all little questions, man. Who said 80? Yeah, here, guys, the right side is for sure something that we can do more with. Sine 2 theta, what are you going to do with that? 2 sine cos? That's it. Like, what else are you going to do with that, all right? So, we have the right-hand side. What would you do with the right-hand side? Nice, Mabasha. The denominator, you should notice that it is an identity. 1 plus tan squared is sec squared. Okay? So before we change anything, let's change that. Then what would you do? Sophia, good. Change everything into fractions. So 2 tan theta is 2 sine over cos. All divided by sec squared. What would you guys do next? What happens if it's 3 theta and not 2 theta? Well, they wouldn't be equivalent. So you can cancel, but the way I like to think of it, guys, is you're scaling. Okay? So you're multiplying top and bottom by something that gets rid of both fractions. Which, Lucas, correct. We are going to times top and bottom by cos squared. Okay? Boom. Here, the cos cancels the cos squared, and we're left with 2 sine cos. And there you go. It's proved, mate. Okay. Part B. Can you start from the right-hand side? Yes, Ibrahim. Absolutely. By using theta is 15 in the above identity, show that tan 15 is 2 minus root 3. Okay, so this sub things in. You'd get sine 30 is 2 tan 15 over 1 plus tan 15, tan squared 15. All right. Sine 30 is a half, right? Then what would you guys do? Skip. Wise pleb. Don't be a wise pleb. Be a not a wise pleb and be smart. I wouldn't change it to sec squared because we need to somehow Fresh Prince, good. It's a quadratic that we need to solve. So guys, I'm asking you to solve for tan 15. Okay? Solve for tan 15. This is a quadratic that we need to solve. It's just usually when we solve quadratics, they're in terms of an unknown, right? So we need to cross multiply. So you have 1 plus tan squared 15 is 4 tan 15. Okay. And then we bring this over here. What would you guys do next? How would you guys go about solving this? Poet dough. Where did I get that from? I subbed in 15 here. 2 times 15 gave me 30. Yep. I would just use the quadratic formula. So technically, guys, we're solving. So if you let x equal tan 15, it would look like this, okay? But we're solving for tan 15 using the quadratic formula. So tan 15 is negative b, which is 4 plus or minus root b squared minus 4a c over 2a. Now, what issue are we going to come across here? Wags. What's the issue with this? Yeah, there's two answers. How do we get one answer? That's a bit of a sticky one still. So we have tan 15. You're going to get 2 plus or minus root 3 based on the answer, okay? Farhad, the negative won't work. But it does. That's actually the answer, the negative one. Why does 2 plus root 3 not work? Indy, cast diagram. Not here. No, not cast diagram. No, not cast diagram. That's not going to help you. Grum, good. You draw the tan graph. There's a particular value of tan. Ah, Iram, good. Pramit, you're on the right line. Okay, yeah, no, you're right. By identifying one value of tan, you know immediately which one is not correct, okay? Now, if you draw the tan graph, we have this. So that's 90 degrees, right? Now, 15 degrees is over here. Now, we're going to compare that against tan of 45. Because tan of 45 is 1. Okay? Well, tan of 15 has to be smaller. Okay? So we're going to say tan of 15. You guys need to explain this as well if it came up in the exam. Tan of 15 is less than tan of 45. So tan of 15 has to be less than 1. Therefore, tan of 15 is 2 minus root 3, as 2 plus root 3 is obviously bigger than 1. Beautiful. Absolutely beautiful, mate. Now respect it. Yeah, guys, it's a show that question. You can't just type in the calculator, man. It's not looking good. Just use your calc, mate. Well done, Omega. Well done. Chris, that was impressive. That's crazy. Eli, would you not get marks if you just pick the one they want? No, because like you're not explaining why that's the correct solution. You can't just get two solutions and say, oh yeah, because you guys want this one, I'm gonna make it that one. That's not the right way of thinking about it. Okay. Okay. Ip dip do, Tobes. Big Tobes. Alright, next one. Show that cos of arc sin x is root 1 minus x squared. Now if you guys remember, I did a question kind of same. We did the arc sine arc cos. If you guys remember, it was something like y equals arc cos. What is arc sine? Do you guys remember that one? Well, I messed all you guys up because you guys didn't have a clue what was going on. It's to do this one, you basically do the way you guys were doing it originally with this question. But make sure you guys go ahead and rewatch this question. It was a very good one. I don't want to do cos of arc sine x. Yeah, what would you rather be doing here? This is Wojciech. It's a Woodjet question, not really. Haha, U sub. We do a U sub. What U sub do we do? There's a lot of people who are going to be lowering the grey boundaries tomorrow. Which I guess is good for some. Mag's good. We let Y or U or whatever be what's inside the bracket. Okay? So we're going to let U equal arc sine x. Okay? What's funny, guys, is those of the students who are saying not in spec, they're trying to deceive you. They're saying it's not in spec, so you don't do the work for it. So then they get the marks, and not you. Ayo, don't fall for it, man. EK Gundogan does mass. Ayo, nah, Wally, you're violin. What do we do next after this? Low Kizzy, for real. Sienna, yeah, good. So we rewrite this. Arc sine means inverse sine, so we sine both sides. So we get x is sine u. Okay? So we know x is sine u. We let that be u, right? We need to find cos u. Okay? So if sine u is x, what can we use to then find cos u? So Cyril, we can use the identity like that for sure. In general, Rowan, exactly. I prefer to use the triangle because if there were coefficients involved, yeah, if I put 2 arc sine, using the identity, guys, becomes very awkward. So in the long run, just doing the triangle is just a bit easier, okay? Even though 1 minus cos squared is very viable here, okay? Now this is x over 1. That's the opposite of the hypotenuse. So the ops is x, the hypotenuse is 1. This will be root 1 minus x squared. Therefore, cos u is root 1 minus x squared over 1. And there you go, you're done. Remember, u was arc sine x. It's an easy question. It's not as hard as the one I did in Cram 1. That was a difficult question. Okay. Sophia, the sine of 90 minus theta is cos is what we needed to use for the other one. Okay. So yeah, pretty simple question. All right. It's easy to do when I'm online, but IRL in exam is cooked. Nah, don't worry. It's not that bad. Okay, cool. R transformations is a good question right here, mate. You guys are going to learn something new today. Yep, cheeky, move on. Adam sails across a river of constant width 14 in order to take a photograph of a water ski racer, Sarah, approaching at 6 meters per second. Adam is 48 meters ahead of Sarah when he starts to sail across the river from the fixed point A. Sarah passes him as he reaches the other side of the river at a variable point B. So bro's running to B. Adam's speed is V, and he moves in a straight line, which makes an angle theta. That should have been here, I guess. Yeah. Theta's between 0 and 150 with the edge of the river. You may assume that the velocity of Adam is 42 over this. Express 48 sine alpha plus 14 cos alpha in this form. Okay, so guys, how do you find R? Why is Adam showing off? How do you find R? Pythagoras, good. They do Pythagoras to 48 and 14. What does that give us? 50. And then to find alpha, it's inverse tan of what over what? Give me the numbers. Those of you saying B over A. Hey, yo, Dominion Melonhead, I know why you're saying that. Hey, yo. Now, in general, guys, it would be second over first, okay? Because I taught you guys that it is inverse tan of second number over first number. But that is wrong here. Why? Why is it not, in this case, second over first? This is why I'm doing these questions, to make sure. Because it's cos. Good. I told you guys that that rule is true if this first term matches with this one. It does not. So this is a past exam question. I basically adapted it. Was exactly the same. They tricked a whole generation of students by just switching them around. We need to rewrite it. So it's 48 over 14. Okay. Give alpha to 2dp and we're in degrees. What does that give us? Couscous. Dion, we're in degrees here. Nice, cred. All good. I'm glad it went well. Enjoy your summer. And I'll see you in A-levels. 73.73. That's a beautiful number, mate. Okay, so what have we got? We got 50 cos beta. Yo, SK. Yo, go 43. Minus 73.73. Shout out Adam running real quick. Given that theta varies, find the minimum value of V. Okay, so V, actually no, it's not V is that, right? V is actually 42 over 50 cos theta minus 73.73. To find the minimum value of V, what needs to be true? Unk. When sine equals 1? Wait, where are we getting sine from? When cos is minus 1? Don't know about that. So you got to think about, do you want the denominator, Jack, exactly? Beaker, good. Guys, you have to think, do you want the denominator to be big or small? That's the only thing that varies, right? So if you want V to be as small as possible, do you want the denominator to be big or small? Exactly, you want it to be at its maximum, okay? So you want this to be as large as possible, which means you want cosine to be 1, which means it's 42 over 50. Okay? Which you can decimalize if you want. What is that? 0.84? Correct, or yeah, I think so. If my year 7 maths is alright there, mate. Cindy, is 74, not 73. I don't know. You guys were telling me 73. 74. Come on, guys. You should be able to round by now. Now I'm going to check it. Inverse tan of 48 over 14. Yeah, it's 7.4. Okay. So, next one. Don't blame us, Unk. Charles. Ayo, Prince Charles, man. I have to give you guys the benefit of the doubt sometime. Given that Adam's speed has the value found in part A, so V min, find the distance AB. Right, how do we find this distance now? Why not -1? Because he's moving forward. V is going to be positive. Otherwise, he's running backwards. Pythagoras, Hola, good. We need to find theta first. It's all about this. We can't do Pythagoras because I don't know what this length is. I can't do Pythagoras with 14 and this base length. We need to find what theta is. Okay. So, if V is running at its minimum, you guys told me that this value of cos needs to be 1. Okay. If cosine is at 1, what angle of cosine gives you 1? What angle gives you 1? Cos of what gives you 1? Matty, good. Am good. Chris, good. 0. Cos of 0 is 1, which means we're making theta minus 73.74 equals 0. So theta is 73.74. So now that you have this angle is 73.74, how do you work out the length AB? Farhad, that depends on the range. So here we want the range to be between 0 and 150, right? So we couldn't make it equal any negatives. So yeah, it's just Sokotoa, isn't it? Which one is it? Oh, Soin, right? Soin is the ops over AB. So we do a switcheroony there. AB is about what? Fishy said 0.360. Oh, no, wait, that says 0.360. Ola said 14.6. ¿Qué pasa? Gain said, use cosec, little bro. What? Hey, yo, nah, you're bugging. Sine rule? On a right angle triangle? I don't think so. 14 point... Hey, yo, nah, you guys are getting different answers again, man. Oh, my days. Oh, we're supposed to be raising the grey boundaries out here, man. I'm heartbroken. It's not looking good. It's not looking good. Hey, yo, that's crazy. 14 point... I'll just say 14.6. Okay. 14.6 good enough meters. Okay, cool. Given instead that Adam's speed is 3.36, find the value of theta. Okay, so that's just equating V to be 3.36. Okay. What's the quick way of rearranging here? Why are we using Soin? Because Sokotoa. Ops. Hype. Trust me, Hamza. Okay, so with the swap, guys, I wouldn't multiply through by the 50 as well. You basically can just swap the cos and the 3.36. Okay, you don't need to do the whole thing. So you have cos of theta minus 73.74 is 42 over 50 lots of 3.36. And I'm not even interested what that is. What do we do next? Oh, is it a quarter? Oh, that's pretty nice. What should we be doing next? Nice, Drew. Cartoon, good. We should be modifying the range. So, guys, the range at the moment is for theta. We need to minus 73.74 to make sure we find values in that range only. Okay, I'm going to do that here. So 0 minus 73.74. Theta minus 73.74. What's 150 minus 73.74? 76.26. Now we inverse cos. What does that give us? $75.52. I get the same. Just remind me, guys. That's the primary value. How do you work out secondary value for cos? $360 minus, good. Which is no point here, right? The upper bound here is this. So this is going to be our only value. So we're going to add 73.74 plus 73.74. 149.26. I didn't specify. Let's just say 149.3. Whoops. Okay. Ish. Thanks, haha. Cast diagram all the way. So, guys, even though it looked like a mechanics question, it's not a mechanics question, all right? It's not even a mechanics-y question. If you remember in Cram 1, I did that geometric sequence with the bouncing ball. That's the only kind of mechanics-y question. You have the modeling with quadratics, but I'm pretty sure modeling with quadratics came up in paper 1, right? I can't remember the paper now, but I feel like it did. Correct me if I'm wrong. I feel like it did. It was cortex, Millie. I thought some... Oh, it was quartic. Okay. But like when you, sometimes you have the modeling questions where they just give you the equation of the thing and they say, oh, how far is it from the ground or whatever, like, you know, that kind of stuff. But I'm talking about EDEXCEL. There's actually, yeah, there was one question in the EDEXCEL that was like this, and you had to find like the tangent or K or something. I actually wrote an exact question like this. So all my students on my main course, we've done a question that was a copy and paste of that. So EDEXCEL just be watching me. It's not looking good. They're just copying all my questions, man. So, yo, Sab. Next one. Differentiation. Now, differentiation of various functions didn't really come up, like using just basic chain rule. So can you guys in the chat show me if you can differentiate 6 to the power of e to the power of 2 to the x? 6e to the power of 2 to the power of x. I can confirm it is not 12e to the 2x. Nobody's got it so far. Abdul. Abdul, you're close. You've forgotten a 2 there. You've forgotten a few things there. Nobody's got it so far. Haha. 6 ln 2 to the power of x. Nice. Haha. I think that's right. Kauthar. Nice. Melonhead. Good. C. I think the chat's moving now, but it looked okay. So, it's good you guys are here. Now, you guys know what I'm like when it comes to differentiation and integration. I can give you guys some absolute vile questions. But the reason I do that is because when it comes to the more simple, traditional questions, it's so basic, okay? So, we want to differentiate 6e 2 to the x. 2 to the power of x, sorry. That would have been easier if it was just 2x, but... Now, when we differentiate that with respect to x, the 6 we call the multiplier, okay? It is known as the multiplier. So that doesn't change anything. And yeah, just as a quick note, guys, make sure you go back to Cram 1 and go through my integration hit list, okay? Now, when we differentiate exponentials, we need to differentiate the power, right? So everybody is being in agreement. What does 2 to the power of x differentiate to? What does 2 to the power of x differentiate to? Prince N, yes, good. So it differentiates to the same thing. Ln 2. Yeah, ln of the base. Then we multiply it by e differentiates to itself, and we keep the power the same. And that's it. That's our answer. Okay. There's other ways we can, like, manipulate this, but I'm not going to do it. I think this is fine. I don't even know how you'd write this so that it looks clean. We could maybe write like 6 ln 2. Nah, I don't think so. I'll just leave it like this. It's good enough. Why does the 6 stay? Because it's a multiplier. Doesn't make a difference. You could do it in brackets, yeah, but it doesn't really make a difference. I mean, you could write like that, to be fair. Maybe that's the cleanest answer. Okay, cool. First principles. Okay, now part B. How do we differentiate that? Gabriel, no idea. Dorian, man, I got you. Poser, what kind of function is this? This is a horror. It is not that bad. Niha, all of these are chain rule. You have to be more specific. Oh, wait, this is the calmest I've seen this guy. What do you mean? I'm very calm, man. Jopkin, good. It's a Pavan function, aka a power function. Okay? Guys, when you say chain rule, you need to be careful. Every single function here is differentiated via the chain rule. Okay? This is a power function, aka a Pavan function. Okay? So if in the chat you put the correct answer, that's good. It means you're a differentiation expert. So when we differentiate this, we need to differentiate what's inside the bracket first. So I want you all to have a go at differentiating this only first. Can you all try and differentiate sine of cosec x? Ayo, Ciara, that's crazy. Let's just focus on differentiating that first. Formula book. Formula book is not helping you with this. So it's not just minus cosec cot. It's not just minus cosec cot. I'm trying to find an answer. Terry. Yes. Okay, so some of you will have done it as well, but I just saw Terry get it right. So when we differentiate this, guys, we have to differentiate what's inside the angle first. Now, remember what I told you guys in the last one. Anything to do with cosec in calculus brings out a negative. Cosec differentiates to minus cosec cot. Okay. Then sine differentiates to cos, and then the angle stays the same. Okay. So that is the differentiated bracket. Let's put that in a bracket. Now, we need to bring down the power and then knock one off the power. When you knock one off the power, guys, it'll become this squared, isn't it? It'll become sine squared cosec x. Okay. And that's it. And now we don't really need the bracket anymore. Okay. So it'll become minus 3 cosec x cot x cos of cosec x sine squared cosec x. If you can differentiate something like this, nothing is going to phase you. Okay. Okay, cool. Lun x. This one's a bit of an easier one. That's long. That wasn't that long. 3-second job. Seb, good stuff. Lewis, good. Matteo. Harry Jones, you're a wizard. That is true. Good. So lun of lun x. To differentiate lun reciprocates the argument. So become 1 over lun x. Okay. You don't even need to write 1 over yet. It just reciprocates, it puts in the denominator. Then you differentiate the denominator to give you the top. That's 1 over x. But then we just scale it. All right. So we times top and bottom by eggs. And then we're done. 1 over eggs ln x. Boom. Okay. Right. Zizi, why do you have sine squared? Because I was bring down the power, not quant off the power. So 3 minus 1 gave me the squared. Okay. Let's take a 7-minute break, guys. Because otherwise your brains will explode. Don't forget there's free resources. Make sure you guys scan this. All right, everybody scan this, please. Get your phones out. Get your phones out. Hey, yo, Pramit. The second one was like a double chain rule, Uma. Yeah, it was. Yeah, just keyword here, guys. It is free. So you might as well. 7 minutes is generous. Time to watch Peppa Pig. So 7:45. Wait, what? 17:45. I'll get back to it. You guys can ask me questions in the meantime. What was I gonna say? Yeah, guys, keep hitting the like button. It helps me out a ton. Helps out the YouTube channel. Thank you. Don't forget, there's also other Cram courses if you guys are interested. Obviously, maths is completely free for you guys, but I think a lot of you are on it already. But if you guys are interested in the other ones, yeah, if you want to sign up for the other Cram courses for biology, chemistry, physics, further maths, I think there's only FS1 and FP1 that are left. Nick's already done FS1. FP1 is next week if any of you guys are interesting. Big up Laura. Shout out Laura, for real. Is integration coming up, AA? Maybe. I mean, I would hope so. Leon, can circles come up again in vectors? What do you mean, can circles come up again? In vectors? And yeah, guys, if you are interested in the other subjects, then you could just scan this QR code. It will just take you straight to the page where you can sign up, okay? So it's up to you. Circle came up in paper 1. Which one was it? That what was the circle one? I'm trying to remember. I can't remember. Jack, do you want to play COD later? I probably will play COD. It depends what time I get home. The radius of 24. Let me see if I can find it again. Who sent me that paper? Who sent me the A-level paper? I think it was Nick. 1 second. I can't show you guys the paper, but unfortunately... Oh, there it is. Circle and vectors. Oh, wait. Oh, no. There's the proof question. They did iteration. 1 second. Question 10. Question 11. This paper's so easy. Oh my god. So easy. Oh, this reminds me. Oh, the circles and optimization. Are you guys talking about that? Is that what you're talking about? I think you're talking about that one, maybe. Guys, you know there was a question 16. No. Yeah, I don't see any vectors. In paper 1 at Excel, I don't see any vectors. Am I bugging? Question 10. Oh, sorry, no, question 10. P to Q is this, QR is this, find P to R, so easy. Hence show that triangle is a right angled and isosceles. That's like the easiest question I've ever seen. In terms of vectors, they can still ask something like a geometric style vectors. But something like this is, they wouldn't ask, they can ask quite a lot with vectors, but, you know, it's probably more on the unlikely side. But guys, I'll find it. I actually did the exact same question on one of the EDEXCEL papers. I did the exact same question. Let me show you. What was it? It was was it this one? Oh no, it's not that one. It's an integration question. No, not that one. Intégration. Thomas. Not that one. When did I do it? No. Here we go. Look at that. Do you guys remember that question? I did the exact same. They used 4. I used 9. So if you've been banging out my videos, you would know exactly how to do this. This was like in the 1900s. Hey, yo. That's crazy. That hair is booging. Nicer, you're violating. So, oh wait, you watched this the night before the exam. It is a tough integral. Here I didn't actually give you the substitution. I explained like why the substitution needed to be done. But in your exam, it was total 7 marks. I didn't write here how many marks this one was worth, but yeah. I'd use substitution to show. Oh yeah, the total 7 marks. I think that's reasonable. Yeah, so this is what I mean, guys. You need to... Hey, yo, nah, that picture's crazy. You guys need to be watching my YouTube videos, man. Why aren't you watching my YouTube videos? That's how you have the best chance. Another one was, what is it? In GCSE, I did a vectors question I uploaded the other day, and it came up the exact same thing. Okay, so goes to show, man. I done all the questions, man. Gellers, you went blank. It'd be like that sometimes. It'd be like that sometimes. Can they give error carried forward in A-level maths? Uma, yes. That's if they don't give you the answer. But in that question, they did say like k cosec squared, I think. So if you got a different k value there, you'll get error carried. The exact correct answer, you need to use the correct answer, not your rubbish one. Guys, I don't have paper 2, man. All teachers get access to the papers 24 hours after the paper's been sat. Yo, Rehan. Hey, I don't even know how to say that name, but what's my split? So in the morning, I have chicken quesadilla or whatever it is. No, what's the chicken sausages called? It's like quesadilla or something. Then lunch, I have chicken, broccoli, and rice. And dinner, chicken, broccoli, and rice. So, yeah, the game's the game. No, it's not a chorizo. And tuna smoothie, of course. Product rule. Something like that didn't really come up. Always chicken. It's not a casserole. Chipolatas, Aaron. That's it. From Lidl. The Lidl chicken chipolatas are banging. So given that y equals e to the 3x sine 2x, show that this is true. Okay, how would you guys do this? How would you do that one, mate? 20 chipolatas a day. That's crazy. So we differentiate it to get dy by dx. This question is essentially a differentiate and substitute. Okay. Would do it by skipping. So bun u and v. Differentiate the first term times the second. Although if you do use u and v, it's all good. It's all good. I forgive you. So you differentiate the first term times the second. Differentiate the second times the first. Okay. So we have 3e3 eggs sine 2x plus 2e3 eggs cos 2x. What would you guys do next? No, we're not solving the further maths way. That's not the point of this question. Callum, good. Acti, yes. So we do need to differentiate again, but differentiating like this, guys, is a bit of a pain, okay? So I would personally factorize e to 3x out and do that instead of having to do product rule twice, okay? So my final dy by dx form is e to the 3x, then 3 sine 2x plus 2 cos 2x. Okay. Now we differentiate again. Differentiate the first term. Easy peasy, squeeze the lemon. Times the second term. Yeah. What? What's the I? Oh, that was for the sine. Why did I put it there? Plus, differentiate the second term. What does that become? 6 cos 2x minus 4 sine 2x times the first term, e to the 3x sine. Okay, and likewise, I would factorize out e to the 3x. I think if there's anything else you can really factorize here. We need to clean this up, man. E to the 3x. Now, at the same time, guys, when you factorize out that e to 3x, that 3 needs to multiply in. So you get a 9 sine 2x plus 6 cos 2x. Then we get plus 6 cos 2x minus 4 sine 2x. So e to the 3x is, what is it, 5 sine 2x plus 12. Yeah. 12 cos 2x. Do you really like it? Is it wicked? Okay, so now we're going to sub it in. Okay, so what we got? We got e to 3x. I love it. Maths. So that's dy d2y minus 6 dy dx. And dy dx is this? Okay. SK, what's my opinion on Heartbroken by T2? Banger. Without your love. So here we got PY. What can we do here? When I hear doop doop doop. Hamza, why can we do that? Finlay, we don't actually need to factorize. What do we need to do? Hey man, how was Lahore? I saw that video. It was good, man. It was good. So we don't need to factorize e to 3x. We can just divide by e to 3x because e to 3x can't equal 0. Yeah? I think once exams are over, we should all go to Taste of Lahore, man. Harrow. Only the one in Harrow. All the other ones. I think there's more, though. So we have 5 sine 2 eggs plus 12 cos 2 eggs. Or even Dubai. Nah, Bond Dubai. Saudi Airlines and that. Now, this minus 6, I'm going to have to expand it. So yeah, minus 18 sine 2 eggs. Minus 12 cos 2 eggs. Lund Airport. Where was it? Was it Zimbabwe? Or Zambia? Can't remember. Plus P sine 2 eggs is Zambia. That's crazy. What do you guys notice here? This is why this question works. Angel, you got no space. Not looking good. Lydia, good. The 12 cos 2x cancels. That's how we know we've done it correctly. So you have 5 minus 18 is minus 13 sine 2x. What grade level is this? At least 0. Plus p sine 2x. What does p have to be then? Kilo. Exactly. Nearly hit dark matter on the kilo. Come on. It's a big question. Like 7? 8 marks? Huge. Easy -1 marker. But there we go. There we go. Damascus. That's a MW19, man. Ayo. End path. Dark matter Casio would be so sick. Imagine if we could get a different camo for the calculator. Okay, quotient rule. A curve. Do we have to know partial derivatives? Only if you're doing further maths. Particular module, further maths. How is P13? Because we need to make it 0, right? So if you divide through by sine 2x, we're looking at the coefficients only, right? Minus 13 plus P is 0. Yeah. Nothing's as good as the bloop bloop. Can you rewatch this live tomorrow, Violet? Yes, of course. So this is... but you guys would have to get this over 1,000 likes. Maybe I'll private this video afterwards. Only if you guys get up to 1,000 likes. Otherwise, it might have to be a hidden link. Only my family's allowed to watch this. Scam, Finn. For a free stream. That's crazy. Private and gatekeep. I'm dead. Nah, Neil does business. Hey, yo, it's a free stream. What are you guys talking about? All right, so we don't use V and U out here, all right? So when we differentiate, it's all love, man. Thank you for the likes. I appreciate it, man. I appreciate you guys. So private then charge a fiver for it. I'm not that cruel, man. So we differentiate the top, which is what? Cos x times the bottom minus differentiate the bottom, which is what? Minus cos x times the top all over the bottom squared. Oh, guys, thank you for the 1,000 likes, man. I appreciate it. I'm glad it's helping you out. I'm glad it's helping you out. What does the numerator simplify to? Okay, I got you guys. I got you. Is this in the formula booklet? Dominic saying 5 cos. Deshaun saying the same. So let's see. So we have cos x minus cos x sin x. This is going to become plus, right? So plus 4 cos x plus 4, no, that'll just be plus cos x sin x, right? Raise it to 1 million likes. Just break the internet. 1 minus sin x squared. Alright, that cancels, you guys. Alright, so 5 cos x over 1 minus sin x squared. Good. So you guys know how to do the quotient rule. Find the coordinates of the turning point of the curve. So what do we need to do here? Marty, can I have your gym routine? I just bench every day, man. That's it. Remember, yet make it equal to 0. Exactly. So we make this equal to 0. Which means that the denominator just disappears, right? So you get 5 cos x is 0. You divide by 5. Cos x is 0. Inverse cos of 0 is pi over 2. What will the secondary value be? Prabhav, yep. I do train legs. You just have to start off with bench press. 3 pi over 2. Some people are noticing something. Because you do 2 pi minus to work out the secondary value. What are you guys noticing? I bench with my legs, Ishak. For real. Cameron, Zercher squats are good. Be careful with your elbows, though. Sana, yeah. So, x cannot be pi over 2. Do you know why? Why can't it be? Nice. The denominator ends up being 0. So, guys, if you set pi over 2 for sine, you get 1 minus 1 is 0. Okay? So, in the range, x can only be 3 pi over 2. Now we just need to find y. Tell me why. When you sub it into here, sine of 3 pi over 2 is minus 1. So you get 4 minus 1 over 1 minus minus 1. What is that, 3 over 2? Okay, cool. Ain't nothing but a heartache. Tell me why, ain't nothing but a mistake. Tell me why, I never wanna hear you say. Why is the numerator 0 for b? Camilla, because if it's not equal to 0, but if we let x be pi over 2, we wouldn't be allowed to have a y value because you'd be dividing by 0. That's why it's not allowed, okay? And then I want it that way. Find the equation of the tangent to the curve with x coordinate pi over 6. All right, what do we do? Peak music. Maybe I need to listen to my Guilty Pleasures playlist now. Gabriel, how do we know when it's wrong to divide values because it loses you a solution? So when you have something like this, yeah, you never divide by x because you'd be getting rid of x's 0. So only if you know x is 0 is not a solution, which very commonly we do in mechanics, t cannot be 0, don't divide by functions of a variable. Okay, so yeah, we plug in pi over 6 into dy by dx. We'd get what? 5 root 3 over 2 over 1 minus a half squared is a quarter. So that's 10 root 3. So we have the gradient, we have the x coordinate, we now need the y coordinate, right? So when you sum in pi over 6, you get 4 plus a half over 1 minus a half, which is a half to 8, 9? I think you guys agree. Okay, cool. So we have y minus the y coordinate is the gradient x minus the x coordinate. Start expanding. Thanks, Mario and Luigi fan. 10 root 3 x, although you've upset Nightbot. We have 10 pi over 6. 10 over 6 is what, 5/3? Pi root 3. What would you guys do here? What form would you... I guess we could just add 9. Should we just add 9? Yeah, let's just do it. The gradient is not a fraction, so you could times by 3 to get rid of that denominator. Just go with whatever the examiner wants. But because the gradient isn't a fraction, guys, I'm quite happy to just leave it like this and be a bit lazy. Still a beautiful answer. Okay. Benji, when is the live stream gonna start? Hey, yo, that's crazy. All right, next one. This is an important question, a question that students neglect all the time, is finding where, or the points where tangents would be parallel or perpendicular to a curve, okay? So it says the diagram shows the curve with parametric equations x equals 2 cos theta, y equals sine 2 theta. Find the coordinates of the points where the tangent is parallel to the x-axis. Now, this is a very simple process. So if they say parallel to the x-axis, they just want horizontal, right? Which would be here. Okay, these points. Yeah, these are the points where the tangents would be parallel. Now, imagine I didn't give this to you. Okay, how would you remember it? Because I don't ever remember what these are. Okay. This is why, guys, bun the formula booklet. Even though the formula booklet doesn't tell you this, you need to know how to derive it, okay? The way to derive it is you basically think, okay, it's a horizontal line. What does not change on a horizontal line? What does not change on a horizontal line? Beaker, good. Tash, exactly. The Y. Tahira, good. Now, because it's in terms of theta, guys, we're going to be differentiating x with respect to theta and y with respect to theta. So it's the y values that do not change. So the gradient of the y values is 0. They are not changing. Okay. So points on a curve whereby the tangent is parallel to the x-axis means that the y values are not changing. So dy by dt or dy by d theta, it depends on what parametric equations they give you, okay? Similarly, when it comes to the x values, all right? So parallel to the y-axis will be here and here. And because it's vertical, the x's do not change, okay? So the x's are not changing. Wally, is this not dy dx? Not this one, not the blue one. You can do dy dx equals 0 for the red, but guys, why are you going to go so far as to work out dy dx when you don't need to? You don't need to divide the gradients, all right? Okay, so let's do parallel to the x-axis. So we need to differentiate. Right. So dy by d theta. Alright, guys. What is dy by d theta here? Kind of like polar coordinates. Basically, yeah. Prevev, yeah. Dark Lord, yeah. So we differentiate the angle. 2 theta becomes 2. Sine becomes cos. Angle stays the same. We're going to make that equal 0, which means the 2 disappears. Yeah. We're also going to modify our range, which is 0, 2 theta, 4 pi. Okay. Inverse cos of 0 is pi over 2. Secondary value is 3 pi over 2. I mean, you should know how many solutions we even want here. Just your average Brit. It disappeared because you divide by 2 on both sides. 0 divided by 2 is still 0. You want 4, right? So guys, 1, 2, 3, 4. Now in the exam, most likely they'll tell you this, but this graph is what? It begins with S. Yep, Danny, of course. Dark Lord pi minus to work out secondary for sine. Symmetrical, good. So once you have one coordinate, yeah, you just use symmetry. Okay, and then you'll work out the others. But let's still go about the full process. If they don't tell you, we can work out the others. How do you work out the other 2 values? How do you work out the other 2 values? Good, you add 2 pi. Okay. Yo, I mean, what's up? So we added minus 2 pi, but we want the positive value. So we're just going to, because of the range. Yeah, another thing you can do, guys, like I showed you last stream, is change that to 8 over 2 so you can see what are in the range, okay? So when we add 2 pi, what does that become? 5 pi over 2? 7 pi over 2. And then we need to divide everything by 2, right? So we have theta is, and I'm going to do it vertically just because we're going to work out all the other coordinates. If they were feeling mean, they would say, okay, you can't just use symmetry here. You need to say the corresponding theta value against the coordinate. But, yeah, it is what it is. Okay, so now with this, we just need to sub it into here. Okay. Cos of pi over 4 is root 2 over 2, so we get root 2. It's probably easier if you just do it into cos first in your calculator, guys. Cos of 3 pi over 4, I'm sure is, because it goes down under, I'm pretty sure it's going to be minus root 2. Then it stays under minus root 2. And then this is root 2. Just check my numbers, guys, and make sure that it makes sense. Then when you sub in pi over 4 into here, you're going to get sine of pi over 2, which is 1. Then the sine is symmetrical above the x-axis. So I'm 3 pi over 2. Is it wrong? That's not good, is it? Which one's which? Cos of 3 pi over 2. Cos of 3 pi over 2 is... Wait. Oh, no, it's 3 pi over 4. So far, it's right. Over 2 unk. Over 2. Cos of... What? Oh, no, you guys rage baiting me. I swear, man. This is crazy. I can't trust... Ayo, TikTok's bug. Alright, fair enough. Whatever. It's right. Okay, Terry said I'm right. And Hamza, I trust them. They're my loyal students. And my other loyal students. So... What about this one? I'm sure this is 1. Then 3 pi over 2 minus 1. Ayo, nah, this is... I can't believe this. How am I letting you guys do this to me, man? Hey, yo. Oh, I'm in degrees. Minus root 2. Root 2. Minus. Man, I can't believe you guys made me check that, man. You forgot the cheeky feta cheese. Sine of 2 lots of oh mate, I'm bugging. Sine of 2 lots of pi over 4. I can't believe you guys are treating me like a GCSE student, man. 3 pi over 4 minus 1. That's right! 1. I literally got all these correct, man. Unbelievable, Jeff. Gonna need some VAR on that one. Okay. Alright, there we go, there we go, there we go. Next thing we need to do is we need to do parallel to the y-axis, which parallel to the y-axis with dx by d theta is 0. So what's dx by d theta here? Whoops, dx by d theta. Dx by d theta. I'm fired. Yeah, minus 2 sine theta. Make that equal 0. Divide by that. That goes. So we get theta is inverse sine of 0, 0. Pi minus is pi. But we can't have 2 pi, so we're not going to do any others, yeah? Nice one, SW. Well done, well done. Okay. What we got? When theta is 0, what do we get? Cos of 0 is 1. So we get 2. And sine of 0 is 0. We already know that. Then this is going to be minus 2, 0. Alex Clark, could you say dx by d theta tends to infinity? No. That wouldn't be for anything. I don't know where you would get that from. Though dx by d theta means that the x values here don't change. So as we go along this line, the x values do not change. Okay? Arjun, for real. These exams are annoying, broke, noob. Hey, yo, it be like that sometimes, man. Okay. Sure, AA. Implicit differentiation. The curve C has that equation. The point P with those coordinates lies on C. Okay, so we'll go term by term. Jalebi, Unk, UCL, or Warwick. They're both very good unis, man. Just go with whichever city you like more. It's hard to beat London, though. Can't lie, Warwick's in a bit of a dead area. It's an amazing uni, though. I'm an Unk, Arjun. Thank you. So we differentiate. I haven't heard that one before. Coventry or Oxford? Yo, Dominion, get out of here. So 4. What does 5y squared differentiate to? Croydon or Peckham Uni? If you don't know about Burnt Oak University, then it's not looking good. Nice. Delft Uni is where we're going. Okay, nice, guys. So you differentiate like normal, so it'll be 10y. But because we're differentiating with respect to x, a function of y, we need to multiply by dy by dx. Okay? What about 5x squared y? Shout out to Burnt Oak Rocket. Shout out to all my people from Burnt Oak. Product rule. If you don't know about Burnt Oak, then I recommend, definitely recommend if you next come to London. So we differentiate the first term. 5x squared goes to 10x times the second term. Plus, I'm too local. I'm a Watling boy. So differentiate y is dy dx times the first. Now 20, you gotta be careful, guys. That differentiates to 0. Okay. If you like your sanity, don't go to Burnt Oak. Hey, yo, nah. Burnt Oak's great, man. They've got a new gym called Jets Gym. It's a vibe. It's a vibe. Hold tight, Burnt Oak Leisure Center. Can you guys differentiate this for me? Minibot, I'm the guy you saw at Brixton today. You'll never catch me rolling through Brixton. Absolutely not. Nicholas. Yep. Liam. So, come spoons after exams. I've been caught in spoons way too many times. Keep it cheap, man. So, 8 is a multiplier, guys. It doesn't change. What have I got against Brixton? I mean, if you look at the state of Brixton now, it's so gentrified that it's not about it. I don't like too much gentrification. I like old school, man. Luckily, gentrification has stayed away from burnt oak. If you guys live near Hendon, Colindale, Burnt Oak, Edgware, you'll know that they've gentrified every single area and they skipped Burnt Oak and they went straight to Edgware. They were like, nah, let's forget about this area. So the multiplier doesn't change. Okay, the multiplier does not change. So shout out Bang Bang and Colindale. I definitely recommend that one. So 3 to the power of x differentiates to itself. Ln of the base. Okay. What would you guys do next? Edgware is not gentrified. Elite trick. If you clearly don't know what's happening with Edgware right now. Gatekeeper Burnt Oak. So we don't rearrange any dy dx. Okay. So guys, we have to we have to substitute. Okay. Guys, when they give you the coordinate, make sure you substitute. Do not rearrange. Do not waste time. Okay. So we're going to sub in x is 1 and y is 0. So we get 4 plus 10. Now, y being 0, actually, you don't even need to write it down. Okay. So we get plus. Just for your visuals, guys, I'm going to cross this out. We don't need that. We don't need this. With x is 1, we get 5 dy dx. 5 dy dx equals... we got 8 times 3, 24 ln 3. Okay. Now we rearrange for dy dx. All right. So we're going to minus 4. Then we divide by 5. Now we do y minus 1. And 10 times 0 is 0. Damn. So y minus the y coordinate is the gradient. Hey, yo, Astro. What are you talking about? X minus 1. I can't lie to you guys. I think that's the nicest answer. What are you talking about, Benji? There's no voice crack. Where did the 3 to the power of x go? I substitute x is 1. Okay. 24 ln 3 minus 4 over 5 x minus 1. That's a clean answer right there. All right, there we go. Voice cracks at Unk status is wild. It's because I haven't had my tuna smoothie. I haven't finished it yet. Related rates of change. All right. We did one like this. If you guys remember the steroid question that I did in Cram 1, the greatest question ever told, make sure you go and rewatch that one. All right. It's giving flashbacks of the cheese question. Ayo, if any of you guys were in Easter revision course, that cheese question was... No, it was an oil question. It wasn't cheese. It was the oil floating in the container. It's not the exact same, but the volume of juice in a large container, V centimeters cubed, when the depth of juice in the water is H, given by this. The container is initially empty and juice is poured in at a constant rate of 120 centimeters cubed per second. Find the rate at which the depth of juice in the container is increasing when H is 7. Okay, so what are we thinking about here? Zinc's potentially at the end, but I did parametric integration in the last Cram course, so you can check out some questions there. So, Erhan, yeah, they've given us dv by dt. So here you can see, guys, this is a change in v with respect to time. And then, yes, a lot of you are saying this is the Wagwan formula. We're going to be using that. So we've got dv by dt. Yeah, that's what we've got. So the Wagwan formula basically tells us that what you want is equal to what you've got times what you need. Okay. Now, what do we want here? The what? Yeah, we want dHdt. Find the rate at which the depth, which is the height, is increasing. So if it's a rate, we want dH by dt. We've got dV by dt. What do we need to multiply it by then to balance it? dH on the top. Yep. Nice. And we need to cancel out dV. Nice, mate. Crikey. And dHdV is going to come from differentiating that. How would you guys differentiate that? Expand first. It's not looking good. I mean, it's not wrong. You definitely don't do product rule. Ayo, guys, that's not good, man. 40 pi is just a multiplier. Guys, you could just differentiate like it is. Like it's the 40 pi is just a constant. You're just differentiating what's inside the bracket. Why would you expand and waste your time? You could just differentiate it as it is. Differentiate what's inside the bracket. What does that give you? Oh yeah, true. This is why I'm showing you guys how to actually be a mathematician, innit? It's all about being a bit lazy. Real mathematicians, guys, are very lazy people. Yeah, I'm not doing all that. I'm not expanding. Such a waste of time. So we differentiate 0.1 e to 0.1 h, and the 1 goes. So there you go. We get 4 pi e 0.1 h. Okay? Is this stream for smart people or nah? It's definitely for 15-year-olds. That's for sure, man. But remember here, guys, you have to reciprocate. So dH by dt is dV dt 120 times 1 over E 0.1 h. And now we just plug in h is 7. All right. Plug it in, mate. What'd you get? Unk. Unk, unk. Unk, unk, unk. Joseph, have I seen GCSE paper 3 today? I haven't. Hopefully I'll see it tomorrow. I heard it was alright, though. I heard it was alright. 4.74. Can I just trust you guys here? Okay, I'm gonna... Alright. Okay, so what is that? What's the units of that, just out of interest? Rich, that's good stuff, man. That's good stuff. Trust me, bro. Geography for you, good. Centimeters per second. Because H is in centimeters, and time is in seconds. Okay. Now here we still want dH by dt, but after 7 seconds. How do we do that? Nice, Lampai. We don't integrate. We do not need to integrate. We don't need to solve it. Because if you solve this, yes, you're going to get h in terms of t, but that is long. There's no way you're doing that. This would be like 2 marks, 3 marks. Hamza, yes. Zincs times what by 7? Ayo, you're close. Not dV by dt. Jalebi, good. So, I told you something very important in the question. I said the container is initially empty. Okay? So the volume is 0 here. But juice is going in at 120 centimeters cubed per second. So after 7 seconds, I know exactly what the volume is. The volume after 7 seconds is 120 times 7, which is 840. Then what do we do with that value? Tuna smooth making unk. Yeah, what are you talking about? Yeah, we plug it into here to find out what H is now. 840. Now, I want you guys to walk me through this because of what I'm going to show you. We're raising the grey boundaries out here. I'm going to show you guys some tricks. Okay. What would you do next? Bromley, yeah, we divide by 40 pi for sure. How many 40s go into 840? Like 21? 21? Is that right? Something like that. Okay, cool. Okay. And then what would you do? What's the next bit we do? What's 9 plus 10? Add 1, okay. Then what would you do? Then Lun. I would not take Lun. This is enough. This is all we need. This is a Neil Does Math special for you guys. Let's hit the like button for the special tricks, guys. I'm making you aware of something really cool here. So let's hit that like button for the Lun gang. I appreciate. What is we don't need to sub in any Luns in here, guys. We can just make the direct substitution. Look at this. Okay. Look at that. Look at me saving you guys some time in your exam. Okay. So thanks, Gru. Thank you guys. So we can now straight away find dH by dt. Love for the support, man. We raising the grey boundaries out here, folks. And there you go. No Luns were needed here. Will this affect Greg's opening times? It might do. It might do. Hey, I got you guys, man. Cheers, G. Save me 1 second. For real, man. It, every little counts. I don't remember who's saying that is. Every little counts. SD rag. For real. No time saved at all. 1.24, Nikki says. Is Tesco? Ayo, nah, bun Tesco. Henry, yeah, okay, centimeters per second. Although, Tesco meal deals are elite. And there's only one correct answer for the best Tesco meal deal. Next one. Thank you, Minibot. Yo, Tesco is not better than Lidl. Get out. That is crazy. So the best Tesco meal deal is the chicken triple sandwich, the Fulfill protein bar, and then the protein drink, which is 25 grams of protein. Or you can get the protein coffee, which is 29 grams of protein. You can't compete with it. It just ends up being like 80 grams of protein. Mariska, it's your meal deal. It's the best one. You can get the protein yogurt, but it's not as much protein as the Fulfill bars. Lidl is mid. You guys are bargain. Okay, a bit more of cheeky reverse chain rule. Sausage, bacon, and egg triple. Nah, bun that. That's just like heart transplant vibes. Who said Waitrose is goated? Waitrose is not goated. Waitrose is like anti-Cozzy Liz. How do we integrate this? Rene, bun Sainsbury's, man. Finlay, good. Fry, good. This is a Pavan function. Am good. We can make guesses here. Okay. So we can rewrite this as cot x, cosec x. Whoops. Cosec. Remember, guys, to go back to my integration hit list from Cram 1. Okay. Now, what's on the inside? Does that directly differentiate to what's on the outside? No, it doesn't, right? But how can we rewrite this so that it does? Yeah, Hassan. So cosec differentiates to something like cosec cot. Okay. We need that to say cosec cot. So we rewrite it by taking out a cosec from the power 4. Okay. And it becomes like this. So now that this is an explicit power function, aka a Pavan function, this is the differentiated angle, or the bracket. What's my guess going to be? Almost bread. Now that I've rewritten it, how does it change in terms of our guess? Bromley, yep. Dhruv, yep. The power goes up by 1. Cosec x to the power of 4. Now we differentiate that. Okay. Now, what does cosec x actually differentiate to? What does cosec x actually differentiate to? I'm a took. Full of a took. If you guys even know what that reference is. So, yeah, minus cosec cot. Okay. Then we bring down the power. And then we knock 1 off the power. So what do we do to both sides now? Lord of the Rings. Damn, you guys know about the Full of a took. So good. Callum and Matt Ben. Yeah, we do minus the core both sides. So here, nice, Mantius. What you want, 1. Damn, you guys got good memory, man. We're raising the grey boundaries out here. So it's what you want divided by what you have. So we're going to do 1 over minus 4. Okay. So there's your answer. Minus a quarter. Cosec. We raising the grey boundaries with this one. RIP to anybody not in this stream. Part B, how do we integrate that? What are we thinking about? Ankiz Gandalf. Thanks, Izzy. Cry, nah. Sana, good. Air 2-pack, good stuff. It is lun. It is a fraction. So our guess is lun of the denominator. Now, technically speaking, you don't need a modulus sign because it's positive. But if you do put a modulus sign, it doesn't make a difference. What does that actually differentiate to, though? Banyu. Moment, thanks, man. I'm Smeagol. Thanks, Mikes. Let's see the headphone then. I don't think it's gonna be that bad. Oh, let's ignore that. Okay, yeah. Okay, that's right. So you got over 2 to the power of x plus 2. Hey, I got Asian hair, man. Allow it. It's thick hair, man. It's because I used Head and Shoulders this morning to wash my hair. So when you differentiate the bottom, you get 2 to the power of x and 2. What do you do to both sides to get what we want? Hey, yo, that's crazy. Hey, yo, yeah, we do 1 over lun 2. We have to divide by lun 2, right? This is the only thing we don't want. So we do 1 over lun 2. Now, I prefer to have the lun 2 in the denominator. So I think this is the best way to represent the answer. Don't forget your plus C in it. But remember, you can also do a normal bracket. Okay. Hey, yo, what's wrong with Head and Shoulders, man? Look how shiny my hair is. That's because of Head and Shoulders. Concave head. That's wild. All right. One of my favorite questions. Integrating sec cubed. By parts. How do we do this? How do we do the integral of sec cube? How do we use parts here? Nice, Hamza. We split it. Yep. Split it, Unk. So we rewrite it as sec squared. Okay. Then what do we do? How do we do parts? I mean, at this stage, guys, you do it whichever way you want. Rowan, for real. We do Liddy. Shout out Rowan's Bowling Alley, if any of you guys live close to Finsbury Park. You'll never really catch me rolling around Finsbury Park. It's different times, man. It's not looking good. So, Liddy. Leave the first term. Integrate the second. What does sec squared integrate to? Neil, come wireless. You will never catch me at a festival. Can't lie. Festival people are not my people, man. Tan, good. Very interesting characters at festivals. You'd never catch me. So we leave the first term, integrate the second, differentiate the first term. What does sec x differentiate to? Comedy show is different. I would go to a comedy show. Finsbury Park is cooked. Finlay, yeah, Melonhead, good. Animation, good. So sec differentiates to sec x tan x. Formula booklet. Then integrate. That's the same. Okay. So we have sec x tan x minus the integral of sec x tan squared x dx. How do we integrate what's in there? It doesn't really help, surely. It might be, Irina. Pavan. This isn't actually a Pavan function, guys, because if you do that, you end up going back to where we started. Zweb, good. We actually need to use the identity that involves tan squared. Which one is that? Because you'll notice what ends up happening once we do that. Yeah, Hamza, yeah. Yeah, that's it, guys. 1 plus tan squared is sec squared. So tan squared is sec squared minus 1. What do you end up noticing is going to happen here? Yeah, it is cyclic. So I don't know if in the last stream, did I do e to the x cos x? I think I did. Yeah. Same concept, different integral. Also, guys, on YouTube, I don't know if any of you watched it. I did this crazy question with somebody said on the Lungang Reddit. It was like this, and it was e to 3x. Like cos 2x or something, and it asked me to find the areas and the ratio between things. Make sure you watch that. That is a mad question. I nearly passed out doing it, but you definitely should watch it. So we expand it. Yes, Moy. Tainan. Link. Just it's on my channel. It's like a recent one. Won't come up, Joe. So sec cubed x dx, the devil one. Is it the one I said the devil woke up and wrote this question? It could have been that one. So it equals sec x tan x. Okay, yeah, it was that one. The devil woke up and wrote this question. I have video on all the trig identities. Yeah, it's all on an A-level playlist for you guys. Come on, man, I got you. I got videos for everything. Guys, if you bang out all my videos, you will do very well. As I showed you before, loads of basically every question that comes up, I've done it before. So now we need to expand that out. Sec cubed x, we need to distribute it. Not enough time. I mean, yeah, you wouldn't be able to watch all of my videos now, but you can do your best. Okay, don't forget, guys, it's a double minus becomes plus. And then we need to... Nice, Shristi. Well done. OCR paper one was a breeze. Shristi, I'm running out of space, though. 2 integral of sec cubed x dx is sec x tan x. Now, what is the integral of sec x? See if you guys remember. Hey, Primate, why are you using so many different accounts, little bro? Okay, good. It's ln sec plus tan. It's a standard result, guys. It is a recip function. So it's going to be ln. Now, if you know what sec differentiates to, you're easily going to remember what it... Ayo Shristi. Nightbot has timed you out. I ran out on the exam. Okay. Shristi, Nightbot is being a bit mean today, but I seen what you said. So sec x plus tan x. Nightbot doesn't like capitals. Okay, cool. And then, because my bot keeps censoring you. Yo. Pramit keeps getting timed out. Free my boy Pramit. How many accounts has he got, man? I know we divide by 2. Is half sec x tan x plus ln sec x plus tan x plus c. And there you go, guys. That's how you integrate sec cubed. Now, in terms of past exam questions, they've not asked this on its own. In a past exam question, what they did was they said first rewrite it like this and do parts once to show that you get this. Yeah, that was part A. Then it said by using an identity to rewrite this, find the integral. Okay. Neil, drink some water. Okay, thank you. I agree, Sophie. How many marks? The cyclic integral was 5 marks in total, the whole thing. Good boy. Oh, yeah. Let's go. One of my favorite questions. Hey, my students will remember this one. All right, the figure. You guys know what I'm like with some of my questions, man. Won't come up. Hey, yo, Andy, Nightbot's trying to silence you, man. The figure shows the design of a logo, ABCD, in the shape of a parallelogram made up of 2 different types of colors. The innermost part of the design is enclosed by a curve, and it's colored white. The rest is colored gray. The design is symmetrical about both the X and Y axis. The innermost part of the design is modeled by an ellipse, given parametrically by these 2. Use integration to show that the area enclosed by this full ellipse is 128 pi. Now, I've already touched on parametric integration with you guys. How do you start this off? Chimwanda, devious laugh. Come on. Nice, Irina. We start off with the Cartesian form. We integrate y with respect to x, okay? So, we need to find the x limits, okay? Now, would you guys go about doing a quarter, a half, or the full thing? How would you guys go about integrating this? So, Lottie's saying do a quarter, multiply by 4. What would you guys do? A quarter? Okay, now, you guys can definitely do a quarter, but I would be careful because to find these values, you would have to make x and y equal 0. If you do just a half, you can just do these 2 and just set y to be 0, okay? A quarter does work though, okay? But just be very careful, all right? Let's just do half and double it. So the first thing we need to do is we need to find these x limits by setting y equals 0. Now when y is 0, you get 8 sine theta is 0. Get rid of that. Inverse sine of 0 is 0. The secondary value is pi. Now how do I know which way round it is? How do I know which one's which? Sub it into where? Not check y. We know y is 0. So we sub it into x. Okay. So by subbing into x, guys, we know which is which. So when theta is 0, x is 16 cos 0. Which is 16, right? And when theta is pi, x is 16 cos pi is minus 16. Okay, so this here is minus 16. This is 16. This is when theta is 0, and this is when theta is pi. What do you guys notice is strange about this? Sienna Neil, why are you giving us such hard questions? Because I'm not going to quote Gordon Ramsay precisely, but I'm not here to make you feel good about yourself, if that makes sense. I'm not trying to be like, oh, look, you know how to do this. Well done, mate. Be quite a pointless stream, wouldn't it? Yeah? Gordon Ramsay does maths. If you guys know about Gordon Ramsay, you kind of know what he says during Hell's Kitchen. But yeah. The problem with this, guys, is can you see theta is 0 to theta is pi? We're going the wrong way. We're going from right to left. Which means I know when I do all my process, inside my integral, there is going to be something which I could just get rid of. What is that? Nice, a negative. So within the integral, guys, I predict there is going to be a negative. I predict a root. I predict a root. So the area is going to be 2 lots of the integral between x is minus 16, x is 16, of y dx. Okay. Now, y is 8 sine theta. How do we change dx into what we need to do? Olivia, because we're integrating the top side only at the moment. Look at my arrow. We're picking up the areas on the top only. Hey, Fatima. Yeah, we need to differentiate x with respect to theta. And here you go, guys. This is exactly where the minus comes from. See? Predicted it, mate. That's what you call experience. Okay? Obviously, being 15 and now, you guys don't know what experience means, but it's all good. I'll try help you guys out. Now, when x is minus 16, theta is pi. And then when x is 16, theta is 0. Okay? Y is 8 sine theta. This is definitely foresight in that. By the way, now I'm listening to T2 Heartbroken. Such a tune. Oh, no. Times dx, which is this sine theta d theta. Now, some of you guys mentioned about the negative. What can you guys do with that negative? Flip the limits. Good. So what we notice, guys, is that the limits are the wrong way around. So we can get rid of that minus and flip the limits, all right? So we get 2 integral between pi and 0. 8 times 16 is, what is that, 144? 128, that's what I meant. Sine squared. All right, how do we deal with this sine squared? No, Rhea. It looks like 1, though. Take out the 128, and then, yes, we need to use the double angle ID to integrate sine squared. I showed you guys how to do that in the last stream. What is that, 256? Which double angle ID are we going to use? For cos 2x, indeed. So, cos 2 theta, Danish bread, is 1 minus 2 sine squared, which we can switch it up. Here's 1 minus cos 2 theta. Now, remember, guys, I told you to keep the half on the outside. Why? Why is that the better option to do? Because, yeah, we can take it out. So, guys, do not write a half minus a half. That's an amateur way of doing things. So, the half and the 256 can combine. All right? So, moving over to here, moving like Shrusti right now. 128 integral 0 pi. 1 minus cos 2 theta. Now, for cos 2 theta, Can you guys... Well, the guess is sine 2 theta. Which becomes 2 cos 2 theta. This is easy stuff now. We want -1, right? So we times by -half. Alright, so we get 128 square bracket 1 integrates to theta. And -1/2 sine 2 theta. Okay. Celine, the minus disappeared and we switched the limits. Okay. Alright, so now we substitute in. Sine of 2 pi is 0. And when you sub in 0, you just get 0 anyway. And there you go. That's proved, mate. Let's go. Let's go, let's go. But we're not done yet. This question carries on. The point P lies on the ellipse, where theta is pi over 4. Finlay, what's the point of parallelogram? What is to do with what's going on now? Did you guys be like, wait, what's the grey bit got to do with anything? So AB is a tangent to the ellipse at P. Show the equation of the tangent AB can be written as this. Okay, so how do we work out the equation of that tangent? Finlay. Okay, we have to differentiate. Okay, cool. So we have dx by d theta. We did that one before. Is -16 sine theta. Dy by d theta is 8 cos theta. So dy by dx is 8 cos theta over -16 sine theta. At pi over 4. There is a nicer way of simplifying this. Do you guys know how you could rewrite that to make it simpler? Not cot, JD, because we're going to have to substitute, right? But think about what cot is, guys. Think about what cot is. Yeah, over tan. So, guys, instead of... So, that is -1/2 cot, right? But because we have to sub in pi over 4, even though they give you the same value, the cot goes to the denominator. It's better to say -1 over 2 tan. Okay, it will give you the same value, though. It doesn't make a difference. But anyway, when you sub in pi over 4, it's going to give you 1 regardless, okay? But you never know. If they had said, like, pi over 6 or something, if I was feeling mean, what do you mean? What do you mean? Then it would have been useful to do like this. Now, when theta is pi over 4, we also need to find out what the x and y value is, isn't it? So when you sub into here, what'd you get? 8 root 2? Yeah. And into here, you get 4 root 2. Is this Wojcik? Is this in the Wojcik spec? So you have y minus the y coordinate is... How do you guys know about old school Skepta? What do you mean? What do you mean? That's crazy. X minus 8 root 2. Expansion. Then add that over and then we're done. Nice. Hence find the exact value of the area of the logo that is made up of grey. Okay, guys, how are we doing that? Act like a waste man, that's not me, young almond. Are you now? Is my wife a teacher? I don't have a wife. I'm married to the mathematics. So the triangle, yeah. So with this, guys, we can work out the area of the triangle. So here we have the height is 8 root 2, right? So where it crosses the is the height, right? The base length, by making y equals 0, we have a half x is 8 root 2. So eggs is 16 root 2. Nightbot putting in a shift. So the parallelogram is going to be 4 lots of a half of the base times the height. What is that? Root 2 times root 2 is 2. Cancels the half. I'm not working out. What's that? Is that 512 then? Because 512. Therefore, the grey is the parallelogram minus the ellipse, which we found to be 128 pi. There you go. And that's your answer. And this was a past paper question. I can't remember the mark distribution on it. Someone could probably find it. It was why'd you times by 4? Because this is only one triangle. 2, 3, 4. It was like 18 marks or something. What example? It was an EDEXCEL question. What paper? I can try and find it. 1 second. Give me 2 secs. It was... I don't even know where to... Oh. No. No, I'm not sure, guys. I would have to find this specific, very specific thing, which I don't think I'll be able to find just Oh, no, maybe it is here. Hold on. Oh, here it is. So 1 second. 1758 is crazy. That was it. So basically the same, but if anything, I've made it slightly easier than what it actually was, but it's basically this, so 2002. Just because it was in 2002 doesn't mean anything, yeah? It's still the same prehistoric question. Yeah, I know you guys weren't born yet. Unc was 30 back then. Hey, yo, this goes to show that the mathematicians were smarter than you guys back in the day. You guys are getting easy questions now. Yo, I'm not making it up. Paper was released in my childhood. Okay, so going back to forming solving differential equations, I did cram course. What is it? Cram course, I did an even crazier question than what I'm about to do with you now. So make sure you guys go and check that one out. Okay. So it says water is pouring into a container at a constant rate of 500 centimeters cubed per second and is leaking from a hole at the base of the container at a rate of 4v/5. Show clearly that that is true. Okay, what do we do here? Back in my day, our question. For real, Josh. Nimra, good. So we do the in versus the out. Okay. In me and Alexander the Great were boys, for real. What went in? What would you guys say for the in? Thanks, Fred Blom. So it is dv by dt. Yeah, so in is 500, good. And then out. So with these questions, guys, be very explicit with your working. Don't just do it all in one go, all right? So it's leaking at 4v over 5. So the net, yeah, it's always in minus out. So the net dv by dt is 500 minus 4v over 5. Then what do we do to get my answer? So Prabha, be careful. It's actually by minus 5. Okay, so guys, I've not just times by 5, I've times by minus 5 everywhere. Be careful, what? So minus 5 dv by dt. Told you, Neil does trickery is always lurking, mate. Then initially, there were 125 centimeters cubed of water in the container. Show that V is this. Okay, so what do we do now? I was going to add that unk. Shy motivation, integrate. Yeah, what do we need to do first? Not wagwan. Separate, yeah, by doing what first? Melonhead, could we times by dt first? Why do we times by dt first? Why do I always tell you guys to multiply through by that denominator first? Callum, yeah, because we need to decide if we need brackets, which we do. Because then to get all the v's to the left side, we need to divide by the whole thing. Okay. Now we integrate both sides. What are we thinking about for the left side? Daily politics, always, man. Bromley, good. Good, Lun. So let's guess Lun of the denominator. Can you guys differentiate that for me? Yo, defect. Nathan, nearly. Not quite, though. Be careful. Ams. Not quite. There's no minus 5 here just yet. Wise pleb. That is very wise indeed. 4v minus 2500. They differentiate the bottom to get the top 4. So what do we need to times top and bottom by? Yeah, so now it's minus 5 over 4. It's what you want divided by what you have. I want minus 5. I have 4. Now, guys, when you do your constant of integration, at this point, just do whichever one you want. My recommendation to you is to always put the constant of integration within the ln. Okay, so ln A. But if you want to write plus C, write plus C. I'm not going to show you that way. But at this point, just do whichever one you're comfortable with, all right? The reason I do it this way is because you can much quicker rearrange for V, okay? So yeah, minus 5 over 4 ln of all of this. My constant of integration is with the A, and now I can start rearranging for V, okay? So we're going to times both sides by minus 4/5. So you have ln of A lots of 4V minus 2500 is minus 4/5 T. Then we e to the power both sides. So you have A lots of 4V minus 2500. Now, when I divide by A, what do I need to be careful of? Adash, what's up? Yo, Anissa. Yo, Ted, what are you saying, dude? How's life? Yeah, you divide by A, it becomes 1 over A, which is just B. Yo, Nick Milk, what are you saying? So this is all standard stuff that we've practiced many times. Then we add 2500. And then you divide by 4, okay? Now, when you divide by 4, like, you get B over 4, but guys, you can just absorb that into a new constant. What is that? I'm assuming 625 based on... No, is it 625? I'm assuming. I'm basically just going up the alphabet. Right. And now we need to sub in our values. So initially, when t is 0, shy motivation. Shout out you, mate. V is 125. Okay. Irina, I'm assuming C is going to be minus 500 for me. Animation sing, yeah. So let's see, we have 125 is C e to the power of 0 plus 625. 125 is C plus 625. Yep, C is minus. Hole, can you hype me up for the exam tomorrow, Unc? Yeah, for sure. I'm a great motivational speaker. You've got this, Hole. So C is minus 500. So I'm going to write the positive term first. Okay. Next one. Feeling motivated. Okay, that's great. That's great. That's great. You're welcome. You're welcome. You've got this, man. Buttery biscuit base. State the maximum volume that the water in the container will ever attain. Okay, what do you think this is to do with? Okay, Nimra, I see you. And quit my day job for motivational speaking. Maybe. AMS, okay. Yeah, so it's not sum to infinity, it's when t tends to infinity, okay? Because this value is going up, okay? It's increasing over time, all right? If I was to show you very quickly, e to the negative looks like this. The minus 500 flips in the x-axis, and then the 625 moves it up. So it looks like this, starting from 0. It's going up, and then there'll be some kind of asymptote up here. But you don't need to sub in a huge value. You can just say when t tends to infinity, what does this tend to? What does this value tend to for large values? Tavone, good luck with your second year ODE, probably numerical methods. What, 3 exam? Good luck, man. 0, good. So as t tends to infinity, guys, e to the power of a negative tends towards 0. Okay, it goes down, down, down towards the x-axis. Okay. Connor, can you just sub in a huge value in though? Yeah, they would. It depends if it's 1 or 2 marks. So if it's 2 marks, guys, you should show this. All right. And then when it tends to 0, V tends to 625. Okay. There we go. And another way, guys, you know that it's going up is because initially there was 125. Okay. So initially there's 125, and you could see that, you know, even if you make t tend to infinity 625, so you know it's going up towards that value. Animation sync. Something like this, I would expect it to be 2 marks. Part B, 5 marks. Part A, 2. Okay. All right, next one. Trapezium rule. You guys asking for a break, but I don't think there's that much left. Before then, I'll ask you guys for... Because after these... Well, these two are really easy, guys. This last question is not hard either. So we'll do that, and then at 7:30, we'll take a break, and then... because that'll be the end of my questions, and I'll leave it to you to tell me what you want to practice more, okay? Okay, guys, let's hit the like button. We haven't done that in a while. If you haven't already, thank you. I appreciate the love and the support. Hopefully this stream has been helpful for you. Has Nightbot... I swear Nightbot hasn't told me to eat. I can't lie, man. This isn't... I mean, it's trapezium rule, but I'm mainly doing this for part B. T, do I ever get weirded out by the comments? I mean, on YouTube it's fine, but you see some weird stuff on TikTok and Instagram. Too easy skip. Zorb Neil does no breaks. Always on the grind, man. So to do the trapezium rule, we should thanks for the likes, guys. We should draw a table, right? So we have X and Y. Who else is streaming 12 hours or even 22 hours over exam season for you guys, man? So you're going from 0 to 3, but what are the increments? take a shot. Nah, never that. 0.75. Yeah, so you're subtracting. You're doing 3 minus 0 is 3 divided by 4. So 3/4 or 0.75. And then 2.25 and 3. Now we sub it in. 3 to the power of 0 is 1. Now here, guys, I would be super lazy. I am not typing that in. I might show you guys how I'll type this in, actually. I'm going to do this via storing, okay? So, I'm going to call this B because of what I'm going to do. I'll show you guys. A, B, C, D, E. Okay. All right, look at this. All right. Look at this. So what I'm going to do is I'm going to sub in 0.75, okay? And what you're going to do is you're going to store this value, okay? So everybody store this value. You're going to do 3 to the power of root A, okay? That. Store it as B. Don't store it as A. I've stored this value as B. Gatekeep storing Vermilion. Nah, I can't do that. Then you press up, go back to this, press calc, change it to 1.5 equals, then store that as C. Up, calc, 2.25, store that as D. Then up, calc, 3, store that as E. So now that I've got all these values stored, it's going to be super easy to just type in without having to write down all the numbers, okay? No one's doing this, Kerpa. Ayo, it's fine. You don't use it, but that's your beef, innit? When your answer is inaccurate. So A is a half of 0.75. It's the first term plus 2 lots of the middle terms, which I only need to write this. I don't need to write any numbers. Plus E. And then 0.5. 0.75. 1 plus 2. B plus C plus D plus E. Easy. Now respect it. 11.6. I haven't said at what degree of accuracy I want, but that's good enough. Okay. All right. Next thing. Have I seen those TikTokers who study online for hours? Hello, hi. I haven't, but I respect it if they're revising for hours. I don't know how they maintain their concentration. Although, it's like accountability, right? I respect that. If you work with someone, it's easy to work for longer. Okay. Use the answer part A to find an estimate for this. How do these two relate to each other? Nice, Harry O'Brien. They do 50 minutes, then 10-minute break. Rowasi. That's Pareto's principle. Pareto! So yeah, guys, all you're doing is splitting up this integral. You're integrating 1. So you split it up. 0, 3, 3 to the power of root x dx. Plus the integral of 1 dx. So the most common mistake is students just add 1 to the answer. It's not looking good, mate. So 11.6 plus. We're integrating 1 between 0 and 3. Okay. So you're actually adding 3, not 1. Show that subtraction, by the way. So you have 14.6 is your answer, not 12.6. How about part 2? We making out the exam hall of this one. Henry, Pareto efficiency. Are you saying, is it efficient? I don't see why it wouldn't be if you use it properly. Yeah, nice, guys. You times by 9. You have to break off the plus 2. So yeah, it just becomes 9 times this. What's that? Did I see someone? What if they change the limits. If they change the limits, they would have to change this as well. So if they could do this, because that just means that the graph has shifted to the right by 1. So these are the same. 104.5. It froze my calculator. Bro's using a Temu calculator. Is it 0.4, 0.5? Ayo, guys, come on, man. Allow it. 0.4. Maybe some of you use the exact answer. But once you've rounded part A, you just use that answer. Okay. How many of you guys remember how to do the staircase diagrams? Neil does mistakes, Ted. What are you on about? Yeah, yo. Pepper can't round. Okay, so you never know, guys. It could come up. They would give you the diagram. They wouldn't ask you to draw it. They need to draw it themselves. And then it's a very simple process. All you need to remember is curved line, curved line. Curved line, curved line. Okay. So solve x squared minus x minus 1 equals 0 by first writing it in this form and using x naught is 0.5 to show, and then show using a staircase diagram how our iterations approach alpha. So I think we all know how to rearrange that to that form. We just move the x and the 1 over and root it, okay? Now let's just generate some solutions. So they might ask you to show some of your working or show some of your numbers. Okay. All right. So where's my calculator? Short for calc, by the way. 0.5 equals answer equals root answer plus 1. Okay. So there's one answer. Let's just do it to like 1.22. Yeah, let's just say that. And then 1.49. Let's just do one more. 1.58. So what you're doing here, guys, is you're starting with 0.5 and you're subbing it into this, right? Now that's your green function. This is y equals x. And this is y equals root x plus 1. Okay. So what you're doing is you're taking that value and with a ruler, guys, you're going up to this and you're reading off the y value. Yeah, this y value here is 1.22. But you need to locate that value on the x-axis to read the x-axis. So you go across to y equals x. Because that y value and x value here are the same. Now that is our next solution. This is x1. And then with x1, you would then read it off this graph. And then you'd read back towards the line. And this is your x2. Okay, you can see that's 1.49. Obviously, my answer is not accurate. But this is why you don't put a number. You just say x2. Then it'll go up and across, up and across. So this is all they want to see. That's your staircase diagram. Easy, right? Just remember curve, loin, curve, loin. Now for curve, it's up and down. Loin is left and right. Up, down, left, right. It looks like some GTA like cheat codes and that. Okay. How many marks? Something like this, like 2 marks. Nothing crazy. So you guys are impatient. Obviously, I'm going to do a cobweb diagram. So let me show you how it would work. So this same quadratic could have been rearranged to give you 1 over x minus 1. All right. Now let's do the same thing with x naught starting at minus 3. Now, guys, remember, curve, loin, curve, loin, curve, etc. Now, remember, guys, curve is up, down. Loin is left, right. Curve, up, down, left, right. GTA vibes. So you go down to the curve. Then we have to go left and right to the loin, which is here, the blue one. So we have to go all the way across here. Okay. That is our x1. Okay, that's our first approximation. Then we have to go to the curve again. Here we have to go down to the curve. Curve, loin. That is our next solution, x2. Then we go to the curve. Then we go to the loin. That's our next solution. X3. Curve. Loin. Then that is X4. Curve, loin, etc. It goes around. Okay? Is it ever line curve, Twan? No. It's always curve first. Because you always substitute into the curve and then you read off the loin. Okay? That's it. So this is a cobweb. In terms of what is the difference, cobwebs, guys, you'll always know which is which. Cobwebs will always have a negative gradient for the curve at the point where it meets the loin. And the staircase will always be a positive gradient. Okay? And that's it. Max is X not always labeled. They would do. They would give you the X-axis so that you know where to start, right? Okay. Is there instances where the staircase or cobweb won't generate points of intersection? Yes, is on. They wouldn't ask you to go into the theory of it. I think I showed you in the main course, right? I did. I remember. Hey, Izan, you know the answer to this, but it's to do with the gradient. So, guys, if this gradient is super steep, yeah, I basically learned this in ecology when I was at university. If that is super steep, then when you go curve, loin, look at this. Look at this, guys. Look at that. Now, respect it. That is prime ecology knowledge. Okay? Now, respect it. Look at all this information I'm giving you guys. Okay? So, it cannot be steep. Basically, the gradient has to be between 0 and -1. As long as it's between 0 and -1, you're good. Ancient era, that's crazy. Unction and bio. Ecology is something else, I guess. I'm showing this to my future grandkids. Hey, Daniel, it's a good task, man. To give to your grandkids. Okay, the unction. Yeah, I learned this in garlic farming. Hey, yo. Alright, next one. I mean, bio doesn't look at the actual maths behind it. Okay, final question, guys. Let's hit the like button. We will be carrying on after this question. It's just these are the questions I wanted to get through. And then I'm going to leave it up to you to tell me what you want me to do after. And we'll do some general revision afterwards if you want to stay. Okay. I'm going on until 9 o'clock. I'm going on till 9. 9. Okay. I was mates with Pythagoras for real, man. Okay, so Newton-Raphson didn't come up. It says the price of a car in pounds X years after purchase is modeled by this function. Use the model to find the value to the nearest 100 pounds of the car 10 years after purchase. Okay, so what are we saying? Exam. Is on. There's not many. So we sub in X is 10. Now, what do we have to be careful of? I don't have an exam, but do more revision than you, Zinks. Ayo, the game's the game. Yes, I know, good. We need to be in radians. Because this is to a calculus, right? So when we sub in X here, guys, you need to make sure you're in radians. And then we round it. What do we get? $3,500 I'm seeing. All right, governor. What? Oh, my days. I even reminded you guys. Hey, yo, nah, you guys are bugging. Get out of it. Hey, yo, nah, get out. Let's move on. Show that f of x has a root between 19 and 20. How do we do that? Too much, mate. Too much. Long day, see a long day. Change in sign. So we need to sub in 19 and 20. This is why I did the storing. So I'm gonna press calc, type in 19, 5, 3, 5, 3, 4, and then we do 20. There you go, minus. So change in sign, change in sign, and f of x is continuous for x being between 19 and 20. Therefore, root lies between. Do I play Roblox? Brev, I'm not 3 years old, man. I did try it and it was so bad. So bad. I actually don't understand the hype with Roblox. Find f dash x. Okay, can you guys differentiate this for me? What does that give you? Do I play Fortnite scrims? I don't. Do I play Grow a Garden? What? That's like Farmville. Ayo, Just, how do you know about Club Penguin, man? That's crazy. Farhat. Yeah, you're close. Oh, okay, I see what you mean. Okay, yeah, that's correct. Okay, so Zweb and Liam, that looks okay to me. So 15,000 is just a multiplier. So 15,000, that doesn't change. Now 0.85 to the x differentiates to itself. Then we learn the base. Okay. Then 1,000 sine x, is that a plus or minus? Minus 1,000 cos x. Okay. By taking 19.5 as a first approximation, apply the Newton-Raphson method once to find a second approximation. Do you guys know what the formula is for Newton-Raphson? Easiest formula ever. Other way around, Sienna, the derivatives on the bottom. So f of xn over f dash. Come on. We don't need any formula booklets, mate. So we have x naught is 19.5. X uno. Hey, yo, I remember this. Typing this in is an absolute pain. Hey, yo, you guys are Utes. You don't know about PlayStation 2 WWF. Here Comes the Pain. One of the best games ever. So you can do answer minus F 1500. Okay, Gramps. Power answer. Minus 1,000 sine answer. PS2 is tough. Over. Proper Utes, mate. 15. Hey, yo, Hamza's still here. That's a W. 0.85. What a guy, man. What a guy. Lun of 0.85. Yusuf. Lun where Unk. What are you talking about? 0.85. Hey, yo, Dark Lord, this is Hamza's job. Bro's getting paid. Bro's getting paid. Okay. Farhad, you got 19.5. Cindy got 528 and Leon got the same. If I press equals, if something's wrong here, guys, I am in trouble. That looks good. I think that's what you guys got. Come on. You thought Hamza was a student. There's Hamza Osman in the chat. Mr. Bowl Haircut. But then there's Hamza Abbas. MES single-handedly funding my summer. My guy Hamza. No, you're not allowed to party too much, okay? You're all banned from partying at university. Partying is not good. Should be on the grind only, okay? Criticize the model with respect to the value of the car as it gets older. What's 5? to 8. That is an 8. What are you guys on about, man? I don't know what you guys are on about. What's it could be a rare classic, Ben. That I don't think that's gonna be a good answer. Did I party? Nah, I'm not a party guy. Good, Callum. So the price goes negative eventually. We've even shown that it's not possible. It's not possible for the value of something to become negative, especially something of material. That doesn't make any sense. Okay, even if it's 0, yeah, it can't be negative. You can't have something of material be worth minus. Okay, this is why the financial system is a scam. Debt is a scam. Okay, try and stay out of debt, guys. Obviously, student loans are an exception. With this model, the price of the car goes negative. Goes negative. Neil does finance. I love that. I would love to make a channel on Neil does finance, which is not possible, as it is a material good. Okay. Neil denies debt for real. What if it's wine? Wakey wines. Am I in crypto? Absolutely not, mate. Okay, so guys, that concludes what I want to do. Now, I'm going to leave it to you guys to tell me what you want to do. But to do that, I actually have made a cool form for you guys to... Oh, perfect timing. It's 7:30. So guys, look at this. There is a form here. Click on that. You have 3 answers. You can do 3 options. So guys, go on that and submit. I'll give you guys like a bit of time. We'll take like 10 minutes or so. But in terms of the questions I want to do, those are my questions. But we can carry on, do some of your questions, like in terms of topic. So I can see like what you guys are voting. So I'm seeing the spreadsheet update itself. So just go through that. And then I can find some questions based on that. But before you leave, if you are leaving, then I'd appreciate if you hit the like button before you go. Usman, I'm not going to do mechanics today because it's EDEXCEL specific, but I've got loads of videos on mechanics. Anti-differentiation is integration. Do you know, like my hit list? So anti-differentiation is the hit list. Those of you asking for domain and range, you could do like modulus functions. Just do that one. The reason it's not... 1 second. Just checking my spreadsheet. Oh, because it is... Oh, for functions, it's in B. Can you see it says vectors intersecting lines and functions? It's in that one. So for domain and range. Circles, Leon. I'm not doing circles. I see a 12 star. No worries, Roasi. How long am I dripping for? What does that mean? I just wear Lungang merch all day. Subtraction, Red. Let's do subtraction. Hussein wants to do parametric integration. Cindy, will 3D vectors come up? I mean, Cindy, I don't know. Mohammed, can I be your best man? What? Bro's getting married already. I'm assuming you're minimum 18 then. Ayo, Sats was good times, man. Misfits. That was a good TV program back in the day. I don't think it exists anymore, though. I got my tips on how to get out of 500k debt. Yo, you need David Ramsey, man. What did I get on Sats, Unk? In year 9, I think I got 6, 7, 8. So 8 in maths, 7 in science, and a 6 in English. Hey, yo, bun English, man. Yeah, I used to have stats in year 9. Year 6, I can't remember. I think I got a 6 in maths, then like 5 or something in science. There used to be stats in year 6 and year 9. 1789. Terry, I did the proof of infinite primes in Cram 1. What's my bench? 150 grams. Guys, can we get the likes to 1500? We're only 17 off. That'd be lovely jubbly. I can get a bit OCD about, like, you know, like whole numbers and that. What I do for my A-levels, maths, further maths, chemistry, economics. Wow, thank you guys, man. Yo, Tanvir, how was your paper 3? I don't know if your brother's in the stream. He was earlier. Andy, optimization came up in paper 1 as part of the sectors. It was good. Nice, Tanvir. It's 120 grams bench at 18 good. Yeah, it's actually pretty good, you know. Kamzo, I've got a gym video on YouTube already. Just search Neil does gym. And I got 2A stars and 2As. Hey, yo, Ishak, allow your brother, man. Nice, Sal Squid. You smashed it. Okay, I'll check the spreadsheet in a minute, guys. Drink some more water. All right. Anti-differentiation is integration. What's anti-differentiation? Can I squat 170 millimeters? Acrylic, what? When am I going back to Lund Airport, Suryaj? Soon, man, soon. Alright, let's take a look at this. Right. Does anyone know how to use PowerPoint? Oh, no. I mean, not PowerPoint, spreadsheets. Isn't there a thing to add a filter? Oh. Oh. Oh, no. How'd you sort by number? Oh, my days. Nah, this thing's bugging. Where's Reese, man? Alt F4. Ayo, Cindy, get out of here, man. Let me ask ChatGPT. But I think we can basically see it. Alright, forget. Alright, number 1 is this. Modeling with trigonometry and parametric equations. That's number 1. Okay, modeling with trig and parametric equations. I can find a question on that. 1 second. I'll highlight this as if we have done one. So some of you guys, I'll find my questions on this because there's not many on modeling with parametrics and uh, trigonometry and stuff. So I'll do one which I did in ERC. Where was it? Was it in day 1 or day 2? I think it was day 1. Ah, here we go. Right. So any of you guys who've been studying with me for enough time. By the way, you will get an email, guys, from us to leave a review. I'd really appreciate if you do that. How many of you guys remember this question if you're one of the OGs? Raw, why did it come out like that? Hi, Minibot. Can you name your kid after me? I don't recommend naming your kid Neil, no. Find something better, man. Let me get the... Right. Let's do it. So you got the motion of electric toy race car relative to fixed origin O is given by this, where X and Y are in meters. Find the coordinates of the car at the beginning of the motion. I finished my Tuna Smoothie. Don't watch that. So here we're going to sub in tier 0. You get X is... what? 1? You guys are going to help me out now because it's been nearly 4 hours of streaming. Cos of 0 is 1. Yeah. Why do you all pick this AO max? Because it's a tough topic. Then when 0 is sine of minus pi minus half minus 5 over 2, I'm thinking. I got 21 seconds to go. Let me know. Find the coordinates where the points where the path car crosses the y-axis. Okay. What do we do there? Thanks, Jazz Skirt. Skirt? Hey, allow it, man. So yeah, now we're gonna set X is 0. Now here, what kind of issues should we be thinking about? Bro, can I read? Hey, allow it, bowl haircut. Can you spell? Ben Gilly. I don't have a way of doing that, unfortunately. You guys are just gonna have to write alongside me. Remember, this is all recorded as well. Maybe take a screenshot or something. So I haven't given you the range, Flory. Good. But we know that we're looking for 4 points. Okay, so we're looking for 4 consecutive points because it's going in a loop, right? So either it's going around this way, yeah, or it's going the other way. Not too sure. Okay, well, I do know because I've done this question hundreds of times now. But we're going to do inverse cos of 0. Now, I haven't really said, but I've kind of implied it. Is it degrees or radians here? Rachel, Rayhan. Hey, I'm bugging. Don't assume it's symmetrical unless they tell you. It's radians because of this pi over 6, okay? So that 45 and 90, they are not in degrees. Yes, that pi over 6 implies. So they most likely would tell you in the exam ways. So this is going to be pi over 2, 3 pi over 2. Yo, Mustafa, hopefully it went well. X, always assume it's in radians. It's probably a good way to go by in general. Now, to work out the... Whoops, that should be over 2. To work out the other 2 values, we're going to add 2 pi, yeah? Ayo, if I'm registering this before you guys say anything, then it's not a clip. Okay, so now we divide by 90. Okay, so we get T is pi over 180. Nayan, hopefully it went well, man. Now, 3 pi over 2, if you divide by 90, what is that? Pi over 60? Correct me if that's wrong. 5 pi over 90, 18 pi over 36? Then 7 pi over 180, I think. Is that right? Jelly, why are year 11s watching the maths A-level streams? Because they're goated, man. They want to work hard. I've taught them well. I'm like, the grind is good. The grind is good. Okay, so now we just need to find the y values, right? Now, the reason I'm doing this question, guys, is mostly for part C. Okay. What we got? We got pi over 180. Whoops. Okay. I'm assuming you guys are not going to want to type that to me. Now, when t is pi over 60, the beginning bits of this question generally are not too bad. It's when we get to part C. Can I leave the rest as an exercise to the reader? That's very common in maths. Yeah? Can we move on to part C? So, you can sub in the rest. All right. Now, part C says, determine... determine how long it takes. It's basically like this. So one will be plus minus, one will be minus plus, etc., etc. Okay. Determine how long it takes the car to complete one complete figure of 8 motion. What is this giving you vibes of? On something that I've done previously. Manti, I'm sure you can sub in pi over 36 and this to get the other two values. Trig modeling, which part? The period of the graph. Good. Air Tupac. Abdul. Good. Hassan. Good. It was the Ferris wheel question. So, guys, I keep telling you, go back to Cram 1. I did that London Eye question. Okay, we'll practice it again. To find the period of the graph, how do you find the period of a graph? So we call it T. Yeah, good. You do 2 pi divided by the coefficient. So 2 pi divided by the coefficient. Technically, I like to use lambda for that. Okay. So where lambda is the coefficient. Okay. Now, essentially representing the frequency. But, you know, physicists, all physicists are mathematicians, but we use like weird symbols for things. So the thing about this, right, is the frequency is different for both of these graphs. This is 90 and this is 45. Okay. Now remember, 2 pi is only for sine and cos. Okay. Yeah, it's circular motion. Okay. For tan, what would that be? Kids, we ain't mathematicians, bucko. Said like a true inexperienced learner. If you do a physics degree, it's a maths degree. And you do a couple of modules that pretend to be physics, but it's actually just maths. There's no such thing as an actual physicist. You're just a mathematician. So yeah, it would be pi. Okay. So if it was tan, it's just pi. But because we're dealing with sine and cos, it's just 2 pi. Okay. So for x, the period for x is 2 pi over 90, which is pi over 45. Okay. And for y, it is 2 pi over 45, which doesn't change, right? Does this value here change the period of the graph? No, because all it does is it moves it left and right. Okay, so it doesn't affect the period. It doesn't affect the time it takes to go around one motion of the graph, right? Now, what do you notice? Which one has the smaller period? Which has a smaller period? And we're going to discuss why that happens. So X has the smaller period. And that's why, guys, it forms two loops. Yeah? The reason it forms two petals, say, is because in the time that the graph or the function goes up, down, then back up, the particle has gone left, right twice. Okay? So in the time that it's gone from middle to top to down and back to the beginning, the graph, the particle, has moved left, right twice, which is why it's looped on itself. Okay? So if we were then going to find out the period to do one complete loop, yeah, the X is cycling every pi over 45. So 2 pi over 45, 3 pi over 45, 4 pi over 45. I'm not simplifying this, etc. This is going every 2 pi, so 4 pi over 45, etc. And from there, you can see that the period of the graph, the time it takes to complete one complete figure of 8 motion is the one that's common in both, 2 pi over 45. Okay? So yeah, the time is 2 pi over 45. Okay? And that's how we do a question for that. Cindy, how many marks for part C? It wouldn't be that much. It would only be 2 marks. We've not done that much work in for that, right? Same as when I did the Ferris wheel question. Flaming. 4 pi over 45 is 2 laps. This would be 2 laps. Yeah? So we've just calculated that it goes up, down, and back up to the beginning. It takes 2 pi over 45 seconds. Okay? Whoa! Okay, I don't know what happened there. Okay, so this better not show up. Where are these questions from, Rare? This is one of my questions. Okay, so that's that one, guys. Maybe take a screenshot of that one. Obviously, this is still saved, right? All right, let's see what the other topic was. Let's see. What's number 2? Vectors intersecting lines and functions. Okay, so for that one, being number 2, I'm going to do a poll because there's 2 there. Because usually when I'm in the main course, guys, whenever I do this with my year 13s, we do this all in one lesson. So I'm just going to do a poll. As in it's combined. So either you want to do vectors or the functions question. So just check that poll. Damn, it's 50-50. Maybe I can go through one each. Alright, it's all good, guys. I'll do one each. Let's just see who YouTube decides is top. Okay, I'll do both. YouTube doesn't know how to add, guys. So we'll do a 3D vectors, then I'll do a functions question. So don't worry, I'll do both. I did do a mad question. Let me see if I have any extra questions. So sometimes I have questions that I've not even done with my year 13s. I don't think I have any 3D vectors ones though. I don't. I've done a crazy 3D vectors question before. Was that in ERC as well? Yeah. It was. I mean, the working is basically the same, but I feel like I've done an even harder one somewhere. I did a ridiculous 3D vectors question. somewhere where the ratio of the intersecting diagonals was like a ratio 2 to 1. Where was it from? 1 second. Think about the online. Ah, it was on. I do have it. It's this one. I won't do this one just because it's on YouTube. Okay, there we go. I'll put this one in the chat. I'll still do another question, but guys, trust me, check this question out. Okay. Like random. I'm gonna do another. Guys, trust me. Save this video. It's nuts. Okay, I'll do this one. I don't want to be hanging about for too long. Don't know why it bugs out with this. Okay. What we got with this one? The diagram shows a cuboid whose vertices are whatever. Vectors A, C, and D are the position vectors of the vertices A, C, and D, as you can see in the diagram. Prove that the diagonals that I've highlighted here in green and orange bisect each other. Okay. How do we do this? How do we do this? Scott, I haven't actually seen AQA paper 1. I don't have a plug for AQA, unfortunately. I wish I did. Collie, good. So lambda and mu. It's a lambda and mu question. And nice, Melonhead and M. It's a sports direct and a sports indirect question. Okay. So the way we do these questions, guys, is you need to approach P from 2 different directions, starting and ending in the same place, okay? Because we're going to do simultaneous equations. All of these questions are simultaneous equations, okay? So, which direction vector would you guys want to do? Which route would you want to take to P? Where would you start? We will be using mu and lambda. Was this in Cram 1? I don't think I did 3D vectors in Cram 1. OP? Probably not OP. You don't always have to start at O, guys. I'll do like AP. AP! Yeah, that's a super direct route. That's a sports direct route right there. Okay. So what I'm going to do is I'm going to go from A to P using 2 different directions. Okay. There's the sports direct route. Yeah, going from A to P. You could have done CP. Yeah, you could have done GP. Shout out Graham Park. FP. I guess those are the only ones. Oh, no. That's EP, sorry. Extended project. So it's up to you which one you guys wanted to do, right? Okay, so A to P. What would you guys say about A to P in terms of the sports direct route? What would you guys say about A to P using the sports direct route? Liam, good. So it's some fraction of the line it sits on, right? So some fraction will use lambda of AG. Now what is AG? What is AG? What is the vector A to G? Nice one, SD Rag. Good luck tomorrow. Yeah, no, this one I did in the Easter revision. Okay, so you guys can verify if that was correct. So you're going minus A. Yes, you're going minus A. You're then going up D. Then you're following this C. Yeah, so C plus D. I just did in alphabetical order. So the vector A to P. Graham Park closed down 10 years ago on Mosin. No, it hasn't. Graham Park is still alive and well. plus lambda C plus lambda D. Okay. Next thing is we need to go the indirect route to P using a different diagonal. How do we go from A to P? Which way would you guys go? No Pythagoras is needed. Okay, so we can go this way. But we still have to start at A, right? So you go AO, OC, and then CP. Okay. All right. So we have AMS. Do I think this can count tomorrow? I have no idea, my guy. That's why I'm just doing questions that you guys want to do. A, O, let's go. OC and CP. Now, AO, let's go, is minus A. Plus OC is C. And what can you guys tell me about CP? Come on. Lambda just means some fraction of. Just means some fraction of. Mu, good. So some fraction. So mu, some fraction of the line it sits on, CE. Now, we're obviously trying to show that both mu and lambda are half, right? So what is C to E using the diagram? What is CE? Okay, well, okay, we'll see if that's correct. So we have CE. To go from C to E, the quickest way, I guess we go this way, that way, then up. So minus C plus A plus D. So minus C, A plus D. All right, cool. So you have A to P is minus A plus C plus mu A minus mu C plus mu D. All right, what would you guys do next? This is kind of light. It's not that bad. So yeah, we factorize. We compare the like terms by factorizing. Okay, so we compare the A's. AP. So we have mu. Whoops. Yeah, that's the weirdest mu ever. Mu minus 1. And then for the C's, well, here we have 1 minus mu, right? 1 minus mu. And we have just plus mu D. Okay. All right. Now what? Now what do we do? Layla, how much would I suggest doing before the exam tomorrow? Not much. Not much. You don't want to waste your energy. I don't know if it's a morning or afternoon exam, but yeah, don't do too much. You need your brain to be fresh. Just look at some videos that we did today or that kind of thing. Yeah, we just compare the coefficients. So afternoon, get a good night's sleep and don't do too much in the morning. So look at the coefficients of C. The coefficient of A, guys, will do the exact same thing. Okay. And then we have the coefficients of C. Megas, you have an history exam in the morning. That's crazy, man. Would be a good highlight here. All right. And now it's simultaneous. So just plug that in. So there you get 2 mu is 1. Mu is a half. And we know mu and lambda are the same. There you go. So we have A to P. So therefore, A to P is a half. AG. And CP is a half of CE. Therefore, the diagonals bisect each other. Okay. And that's proved. But guys, make sure you watch that video I've just pinned, okay? Because that's an important one. It's much, much, much harder than what I've just done. What does it mean by they bisect, Gabriel? They cut each other in half, basically. Faria, how do I make my brother watch your stream? He isn't revising for his test tomorrow. Unfortunately, Faria, you can't force him to do anything. It's his choice to revise or not. But good luck to little bro. Vova. Well, Nick did a FS1 stream yesterday. So if you're interested, you can contact customer support and ask them how you can get access. Would it change? What would change if it was a ratio question, Hasib? It wouldn't change anything. The working out is still the same. Okay. How does it prove? Because both of them cut halfway. Okay. So both are a half. Half, half. It must mean they bisect. So mass bisect means directly in half. Like half, half each way. Okay. Okay. The next thing you guys said was... we need one more person for 1,600 likes, by the way. Who's going to be that person? WW. Functions, you guys said. Nice. W Lungang. What do we say? Function S. It was you. It was me. It was me, man. It was me. I swear. It was me. Thanks, Nathan. Thanks, Hamza. Okay, so composite domain range. I did actually have a question very recently on that. Where was it? Let me remember. Hold on, guys. I'll try and find it. Composite domain and range. Is that what you guys want? I don't know if that's actually what you guys want, though. Those of you who wanted functions. Obviously, it's quite generic, right? Okay, hold on. Hey, yo, you guys are cooking my brain now, man. Composite domain and range. Why are you guys doing this to me, man? Easy stuff. Let's see if it's here. It wasn't there. When did I do it? Maybe it was a paper. I think it was a paper. When you guys ask for domain and range for composite functions, you're asking for something very, very niche. Very niche. Was it this? Oh, there it is. Okay, I found it. Yeah. Can't bother to find the actual mics. Yeah, we do. Domain expansion. I don't even know what that is. Everyone keeps mentioning domain expansion. Hey, yo. Okay. Here's the question. Some of my main course students, you might have seen this. It came up in my homework 17. Shout out to my students, you know, the position they're in right now is crazy. They're smashing it. I've done Ferris wheel questions already. Yo, Brian, I haven't done the homework since September. Shout out you, boy. Can I zoom in? What? Alright, there you go. Like, you are my students as well. I mean my main course students. Okay, so I don't know if there was a domain range question, Cram 1. I think there was, but not like this, not with composite functions. So here's one of my questions. It says the functions f and g are defined by f of x is x squared minus 9, with x being bigger than 5. And g of x is 3x plus 1. State the range of f of x and the range of g of x. Okay, so find the range of f of x and g of x. What would you need to do? Well done, Ghosty. Neither is anybody else. Draw. Good. So we sketch. Now, x squared minus 9 is super simple, right? It's just the x squared graph that has moved down by 9. Okay, that's what it looks like. But what would be good to find here? Probra, that's not a good way of doing things. Don't just sub in x and then sub in a large number. That's a bad way of doing things. That doesn't always work. So the roots for sure, because we need to know the position of x is 5. Now, when you find that, that is 3. So 5 will be slightly to the right of it. So yeah, we're going to plug in 5. What is that? 5 squared minus 9 is 16, right? And we want this part of the graph because we want bigger than 5. So we want that part. So we have f of x is bigger than 16. Yeah, and minus 3, but I'm not interested in minus 3. Okay. Try not to sneeze. 1 sec. Okay, it's gone. All right, next thing is 3x plus 1. Right. Pineapple? What's pineapple got to do with it? 3x plus 1. All right, so that's like this. Do not hold in your sneeze. Why? Makes you not sneeze. I'll remember. Yeah, H7, you know it is. Now 3 over here. So it's very similar, right? What is it? 3 plus 1, 10. I want more than 3. Okay. So we're more than that. So g of x is more than 10. G of x is more than 10. Rigid. Nice. Oxford offer. Well done, dude. Find a simplified expression for f of g of x. Okay, now f of g of x means f of g of x. Which is f of 3x plus 1. Yo, Matty, learn gang. Do you not need set notation? Nope, it didn't ask for it. Remember, guys, if they don't ask, don't do it. Just put the fries in the bag. So we have x is changing to 3x plus 1. So we have 3x plus 1 squared minus 9. It's up to you if you want to expand that. I don't think it's I don't think you need to. They'll tell you in the exam what they want. I guess part C is what you guys have all been asking for, right? Determine the domain and range of f of g of x. Okay. Now to figure out the range, there's a few things we need to consider here. So you have x, All right, and you're subbing in x into g, and whatever that is, you need to sub into f, right? Which is a bit of a mad one. Well, dash into the CG50, it's not going to help you here. So you have your input x, okay? And you're subbing that in to your function g to get g of x, right? Let's just focus on that for now. So now the x values that you can sub into g are x is bigger than 3, right? And when you sub in x is bigger than 3 into g of x is then bigger than 10, okay? So these are the possible values which you can then sub into f. Because remember, guys, you're taking g and you're subbing it into f. So you're taking these values, yeah, and you're subbing them into f. So this becomes the new inputs that you then sub into f. Okay? So now, yeah, those g of x is greater than 10. Those numbers are the ones that you are subbing into f. All right? So you're now restricting what you can sub into f. All right? Which changes the range of f. This old range is now different because the values of x that you can substitute in have changed. It's not x is bigger than 5 anymore. It's x is bigger than 10. Okay? Yeah, Isho, exactly. So this is changed to 10. And you just have to read that off. Okay, now when you sub in 10, you get 10 squared minus 9 is what? 91. So you want those values. So there you go. So the values that you can have for this, which is fg of x, is that they have to be bigger than 91. Okay. What if the new one was less than the old one? Well, then you'd have to prioritize the old one because for the old one, x has to be bigger than 5, right? So if this was less than 5, then you would have to prioritize the 5. Okay. It's quite simple, right? For that range. Okay. So the range is simple. The domain, there's nothing hard about the domain. The domain, you know, we had f of g of x. Okay. First, we have x is bigger than 3. All right. So that's the first condition. The next thing is that f of x, the x values had to be bigger than 5. Okay. You just have to make sure that this function x is bigger than 5. Okay. So there's two things you just need to make sure that you ensure is true. Okay. So in terms of our domain, x has to be bigger than 3. Yeah, that's for g. Then for f, we have to ensure what we substitute is bigger than 5. So it's an and statement. Yeah. Is g of x has to be bigger than 5. But g of x is what? 3x plus 1? Which is what? X is bigger than 4/3? Now, which inequality satisfies both? I couldn't hold it in, man. Oh, damn. The camera went blurry, man. Yeah, x is bigger than 3, so that's your answer. Thank you. Thank you. Thank you. Let me configure this. All right. Sneeze on blurriness. So yeah, the domain is x is bigger than 3. That's how you do these kind of questions. Thank you, thank you. Thank you, guys. I appreciate it. So there you go. There you go, guys. That's how you work out domain and range for FGX. It's very simple. Remember, we've been doing maths for nearly 5 hours now. Can you all promise me you're going to rewatch this in the morning as well? Ola, there's actually not many questions like this. Off the top of my head, I just know that this one exists that I wrote, but I can't really find many questions like this. So if you watch it again, yeah, maybe timestamp it. I don't remember what the time was when I started this, but right now it says 4 hours 19. So maybe go to 4 hours 15. Something like that. Just watch it again in the morning, okay? So, yeah, that's that one. All right, next thing. You can watch the playlist I made instead, for sure. Say 9, Unk. Perk, Professor. X is greater than 5 had to be what you sub in for f of x. f of x, x has to be bigger than 5, but because we're subbing in g of x, that function has to be bigger than 5, okay? Don't worry, I got you guys, man. I got you. Trying to make sure you all get the best grades possible. We're nearly on 1,700, guys. Only 8 more people. Can we get above 1,700 likes? Love for that. I got you guys, man. I got you. Next one. Let's have a look. My brain is so fried, man. Where was it? Where's the spreadsheet? Here. Okay, so that was now the new number 1. Thank you, guys. I appreciate it. 1, 2. Where's 3? Guys. Oh, why are you doing this to me? I'm assuming you guys mean applications of parametric equations. Is that what you guys mean? Imagine a 12-hour stream. I'm well experienced with big streams. Kieran. Neil, drink some water, you basket case. All right. Okay, right. Well, parametric integration is down here. That was number 4, so we probably will get to that anyway. All right, let me see if I can find something. Give me 2-3 minutes. Archimedes cut for real, man. Let me see if there's questions that I've not done with my year 13s before. Otherwise, I'll find something that is one of my own written questions. Because again, all these applications, guys, there's not many questions on them. But don't worry, I'm always prepared. Bro, where's the extra questions? Oh. Applications. Applications of parametrics, you said. Okay, it's not a question in terms of one I've not done before. No, before that. Wait, the applications, I think I basically did that. That's the one I just did. One sec. Oh, so when I say applications, guys, it's basically applying it to slightly different questions. Let me find you an interesting question. Something like this. I don't think you guys would find this one too tricky. It will only take us like a couple of minutes to do. But this is like applications of parametric equations, something like this. So we've done modeling with parametric equations. This is like applications of parametric equations. Nice, Samad. My guy. So a curve has parametric equations x equals at minus 3. Y is a lots of t cubed minus 8. Where a is a constant. The curve meets the x-axis at minus 2, 0 and the y-axis at a. Find a and the coordinates of large a. Okay, so how would you guys do this? Brazil visa questions. Damn, that's a tough one. I don't know any questions for that. Did we just substitute? Yeah, big M method. Tell ya, bro's talking about D1. That's wild. So we just sub this in, guys. Work out what A has to be. Okay, we don't need to find the Cartesian equation here, guys. When it's parametric, always work with the parametric equation, all right? Nothing else. How would you work with this? Yawali, Yibble. Nobody, I don't think, voted for the binomial expansion. I've got loads of that stuff, though. Ahmad Gee, Unk, is UCL still good for computer science? I mean, UCL have just renovated their computer science building. It looks insane. So yeah, I mean, UCL, you go for the name, man. All of these unis, you go for the name. So we substitute. There's actually something I can see straight away. Good, Savo. And Terry, good. You can solve for T. Who can tell me what T is based on all this information? Jelly Buff is a good uni. Taste of Lahore sponsorship when? Ayo, Callum, I need it soon, man. Dominic, good. Aaron, good. So, when you guys look at this, you can actually work out what T is because you have two things multiplying to give you 0. And A is a constant. Maybe I should specify it's a non-zero constant. But we're not obviously looking at A being 0 because if you substitute A as 0 here, you'll get -2 is -3. So we already know A can't be 0. Okay. So A can't be 0. So we have T cubed minus 8 is 0. So T is 2. And then we just plug it in. So we add the 3 over. 1 is 2A. A is a half. Don't know why I wrote it like that, but to then find the coordinates of A to find where it crosses the y-axis, you just make x equals 0. Now when x is 0, you get a half T minus 3 is 0, which is what? T is 6. Some of you guys are saying 104. Is it Santa Claus? A half 6 cubed minus 8, 104. Do you guys agree? Dark Lord Neil, how will the 12-hour math session work next week? Well, I guess I just do it, right? If A isn't 0, how do you solve for T? Bromley, you wouldn't be able to do it. It would have to be done in another way. Yeah, they would have to give you more information. Albus, thoughts on University of Birmingham? As in, it's a good uni. It's a Russell Group uni, right? Okay, what we got? What was it you guys put? 4. Where was that? Here. 4 is... Okay, so with this one, guys, you guys are all doing parametric. What are you guys doing to me, man? I'm assuming you guys want parametric integration. Huh. Hop on Fortnite. I don't play Fortnite anymore. I did back in 2018, maybe. Now it's all about grinding camos on Black Ops 6. Alright. You guys are basically making me go over the whole spec again, man. Let me see if there's one that I've not shown you guys before. Nope. Was there another... Do you know those old school questions I was showing you? There might be a good one. Ooh. Didn't parametric integration come up? Or am I bugging? No, it can't have because I've just done it with you guys. Okay, I'm gonna do another Unk question with you guys. No, okay. You guys ready for another Unk question? I love this question. It's very similar to the one we did already. So now this is YOLO maths. Ayo, you guys asked for it, man. You guys asked for it. I'm doing this to myself as well, okay? So speed shorts, chop the loadout. I'm grinding camos, so I don't have a best loadout. Differentiate. This looks light, Kishan. Maybe. This might have to be the last question that we do. How many marks is this? 15 marks. You never know, man. So it says part of the design of a stained glass window is shown in figure 2. The 2 loops enclose an area of blue glass. The remaining area within the rectangle ABCD is red glass. The loops are described by the curve with these parametric equations. Find the Cartesian equation of the curve in the form y squared is f of x. All right. What would you guys do first? So if they're gonna ask something like this, guys, it's gonna come at the end of the paper. Yeah, nice. Najo convert sine 2t. By doing what? The double angle ID, yes. So what we got? X is 3 cos t. Y is what? 18 sine t cos t. Okay. We can replace x. X over 3 is cos t, right? Love a challenge, man. But sine t, what are we going to have to do with that? Actually, I would do something first because of what the question said. Yeah, flaming good. I would actually square everything first. Okay? Because of the form the question wants it, we're going to square both sides. Okay? So yeah, y squared is wherever 18 squared is. I can't even be bothered to work that out. And then we have y squared is 18 squared. Sine squared is 1 minus cos squared t. And then 1 minus. So you get what? X squared over 9. X squared over 9. What would you guys do here? Kind of like polar coordinates. Yeah, Hamza, I would factorize out the 9. I personally would not multiply in the 18 squared and the over 9. I would personally factorize out the 9. So you guys saying it's 324. So 18 squared is 324. Then this over 9, yeah, this one, I would take on the outside. Yeah. And then you times everything on the inside by 9. Okay. So you can do 324 over 18. What's that? Connor, yeah, you can expand it all because they haven't given us what they want. You're fine to just expand it all. I just don't think it looks very clean if you do that. Ola says 36. Do you guys agree with that? Okay, cool. And then I'd write the x squared first. 9 minus x squared. That is the cleanest answer for sure. Poppy, so that the shaded area is that. Is this a legacy paper question? I'll let you know what year this question was in a second. Okay, so 18, little bro. Hey, now you guys. Wait, I get 324 divided by 9 times 9 is 4. Wait, what are you guys doing? I get 4. No, I said the 9 here. Wait, it's not Neil does mistakes. I asked you guys to do it for me. 3, 2, 4. Ayo. You guys are too sleepy EP, man. On the denominators, you're multiplying them, innit? 4. Okay. Silly you guys. Ah, silly yous. It's all good. I forgive the Lung gang. Fuck me. Show the shaded area. Pramit does mistakes. All Pramit's for real, man. Is given by this. Okay, so we need to find that constant name. How do we start this off? Ah, you guys, mate. It's all good. It's all good. It's all good. AAE. But I had good. So we do the integral of y dx. Okay, so we start off by doing this in the Cartesian form. And then we need to find the Cartesian limits. Okay, so between here and here. Now, obviously, this is x is 0, but we need to find the other one, right? And if you guys can't see this, but that says pi over 2. But that's the t value. So we need to find the x value first. And that's going to come from making y 0? Yeah. Divide by 9. Inverse sine of 0 is 0. Then we have pi Now, realistically, obviously we can keep going, right? We want the one that's relevant to us. Okay, so we can divide by 2. These are the things I would write down in the exam. Okay, so I'm basically showing you guys what I would write in the exam. But we need to just check the x value, right? So when t is 0, I already know. Actually, interestingly, when t is 0, guys, you get 3. So that must be in this one. X is 3, t is 0. Uh-huh. When t is pi over 2, that's when you get x is 0. What does that mean about when we put this in the integral? What do you know is going to happen? This is basically the exact same as my other question. What do you know is going to be inside the integral? Ayo, good stuff. Hola. Hola, ¿qué pasa? Yeah, it's going to go backwards. It's going to be a minus. See? Guys, I'm turning you into parametric integration experts, okay? You know what's going to happen, all right? So, we have the area is the integral of x is 0 to x is 3 of y dx. Now, when x is 0, t is pi over 2. And am I doing stats or mechanics first in the 12-hour stream? I am doing mechanics first. And t is 0 when x is 3. Y is 9 sine 2t. And then we need to change dx into dt by differentiating, right? That's easy. Where's that? Minus 3 sine. There you go, guys. There's that negative, right? Easy peasy, squeeze the lemon. So yeah, guys, the negative, we get rid of that. So now you know what A is. A is 27. Right. Now evaluate this integral. So how are we going to integrate this? Are we ordering a large whole chicken for that stream? Most likely, yeah. Double angle. So before, we can't guess just yet, guys. We need to do the sine 2t. We need to change that. That becomes 2 sine t cos t. Now, you can obviously do that in stages. I'm just going to write it here. That's 2 sine t cos t. And then you guys are right. It does become a Pavan function. 2 times 27 is 54, which I'm going to bring on the outside. I'm going to write the cos t first. And then sine squared. John Doe, maybe flick through the stream and look at topics. I usually have the topic name on the top here, so you can decide if you want to rewatch a particular part or not. So this is a reverse chain. What? A reverse chain rule question. What's my guess gonna be? Hey, you guys need to go to sleep after this, man. Nah, definitely not parts. So this is the differential of. So this is the differential of the inside. So we're doing the reverse chain rule. It's a Pavan function. We expect the power to go up by 1. Now, when you differentiate that, sine differentiates to cos. Then we bring down the power, knock 1 off the power. Even when I'm sleepy and delirious, I can still do maths all day, man. Then that third and the 54 combine to make what? What's 54 divided by 3? Like 18 or something. You guys can correct me if it's wrong, but whatever. Sine t cubed between 0 and pi over 2. And then sine of pi over 2, 1. So 18 minus 0, 18, I think. Yeah? Thornton, my school didn't teach us reverse chain. Hey, yo, it's all good, man. I'll show you now. So good. If you guys want to revise your reverse chain rule, go to Cram 1 and watch my integration hit list. Good boy. The sides of the rectangle ABCD, given in figure 2, are the tangents to the curve that are parallel to the coordinate axes. Given that one unit on each axis represents 1 centimeter, find the total area of the red glass. Now, which was the red glass? 2 loops enclose an area of blue glass. And the remaining area is red glass. So this is blue. So this bit here, guys, is blue. And the bit on the outside is red. So we need to do the rectangle minus the looped area, right? Look at that artwork, mate. Okay, we're back on I'll bring you flowers. Okay. This reminds me of, do you remember when you guys were youths? You guys are probably won't remember this, but you used to be able to get glasses with one blue and one red, and you're looking at it, things would be in 3D. Hey, yo, you guys probably won't know about that, Peppa Pig watchers, but this is what 3D used to be for me. Spider-Man. Hey, yo, why you guys acting like you know what that is? Hey. Okay, Hunk. Okay, Hunk. Okay, now, do you guys want to learn a cool trick? How to do this like super quick? Shall I show you guys how to do this like insanely quick? Like for 4 marks, I can do this in like 3 seconds. Okay? If you want me to show you the trick, let's get it to 1,800 likes. No, I'll show you guys this mad trick. Bun these lines. This is what I do in my exam. This is why I was like finishing my exams in like 20 minutes. Let me show you guys how to do this super quick, yeah? Bro is farming likes. Hey, yo, don't be a hater, man. So, we obviously need to work out the... Thank you, guys, for the 1,800. So, we need to work out the base length of the rectangle, right? Now, the tangent here, this tangent... What you guys could be thinking about is dx by dt is 0, right? Do you remember I showed you that? We don't need to do all that. That's all just like, unless they ask you for the point, you don't need to do that. That tangent is the furthest, or is at the point which is the furthest away from the origin, right? This point here is x max, the biggest possible x value. What is that? What was the biggest x value that this could be? We basically did it earlier. It's 3, Hassan, exactly. Yeah? This value is 3. It's the maximum value of x when cosine is 1. Which means this is minus 3 due to symmetry. So I already know that base length is 6. Using that same logic, what is the maximum value of y? What is that maximum value? Kishan, exactly. It's 9. Misty, good. Look at that, guys. We raising the grade boundaries out here, man. So this whole thing is 18. Yo, look at that, mate. Ay caramba. So we can work out the area of that rectangle, which is 6 times 18. And then we are minusing the area enclosed by the loop. But guys, you have to be careful. That was 18, so we have to times that by 4. Okay, which is easy because if you factorize out the 18, that's just 2 times 18, which is 36. Look at that, 4 marks for that. Hey, yo, ay caramba, man. Look at that. This is why I finished all my exams in like 20 minutes. It's about the tricks, man. Thought of where the 9 come from. It came from here. That 9 over there came from there. That's the maximum value of y. Centimeters squared for sure. You could write that if you want. 4 from where? I just multiplied 18 by 4. Each one of those are 18. How else could you do this, Ben? If you do dy by dt is 0, find out what that point is, find the y value, find its height like that. Okay. Is it? Would you still get method marks? Absolutely. Yeah, you've shown a proper method for getting that solution. Okay. So yeah, so that's 2 lots of x max. And this is 2... sorry, that one is 2 lots of y max. Okay. How do you know it's symmetrical? Because it's a cos and sine function. They are waves, right? So they repeat. So it has to be symmetrical. It would be different if there was a plus and minus. Okay. Okay, we raising the gray boundaries with this one. But they wouldn't give a question with like 3 plus 3 cos t. Like it doesn't make any sense. It wouldn't make sense with regards to the question. Okay. Kalthar, the 2 times 18 was just me factorizing out 18 from here. You could just type in the calculator though. Okay. Finley, what year was this? This one was 2001, question 8. 2001, question 8. It was a P3 paper. Damn. Like 1800. Bruh. Alright, what are you guys saying for the next one? I think we'll do one more. It's been a productive session. Which one's number 5? Modulus functions. Okay, you guys want modulus functions. I might have another one, another interesting question on modulus functions. I had Epic Games because the kids wanted me to play Fortnite. Right, where we are. There we go. Here's an interesting question on modulus functions. I don't have my controller. I can't play Fortnite. My controller's at home. Okay, I've already done recurrence relations today. You can definitely check that one out. Me gusta. It's not that bad. It's not that bad. Wags, I explained the 4 times 18. It's just 4 lots of the quarter loops. So f of x is a minus modulus. This question was from 1857, by the way. A minus modulus x minus 2a, where a is a positive constant. Sketch f of x. Okay, now, where would the vertex be? What would the coordinates of the vertex be? Hunk question. 2a what? Is it Alam? Okay, so remember, guys, this is basically like having a completed square form, right? So it's the negative of this number, comma this. But what do you know about the V taper? Because of that negative. It's an upside down, Amelia Good. It's an upside down V. So it's 2a, comma a, but it's an upside down V. Okay. Where does it cross the y-axis? Got that X taper. Is it a or minus a? So when you make x equals 0, yeah, you get the modulus of minus 2a, which is 2a, but you have a minus 2a. Okay, so guys, when x is 0, you have a minus the modulus of minus 2a, which is a minus 2a, which is negative a. Okay, so be very careful with that. So something like this. Okay. Find the value of the integral between 0 to 3a of f of x. So we're now integrating a modulus function. How would we do that? defect. I was just saying you're comparing it to a completed square form to find its vertex. Aina, so 2A is the turning point indeed. Yeah, Jalebi. It's just triangles. Tan W, good. So this isn't a case of, look, you need to find the integral. This is a question where you just need to find the area of triangles, okay? What makes that slightly difficult at the moment? Joe, you're on the right line. What makes this a bit more difficult at the moment? It's not the negative areas. Yes, Rubu, good, good. We need the roots. Janet, good. Because we don't know. There's parts under, there's parts above. Yeah, we need to know where these points are, so that we even know where 3A is, okay? Now, you don't need to simplify anything if you don't want to, but who can tell me what the equation of that line is? You don't need to expand anything or anything like that. I wouldn't recommend subbing in x is 3a. Joel, a minus bracket minus x. Minus, oh wait, what have you done? You've multiplied it by minus inside. Ah, that's what you've done, Joel. Emerge, minus x plus 2a. Okay. Brian, remember it's a positive gradient, right? So guys, you have to be careful. Parts of the graph were reflected, right? So the equation of f of x is a, and it can be plus or minus whatever this is, depending on how we reflected it, okay? So what I tell students to do is to just look and decide, is this a positive or negative gradient? Well, it's a positive gradient, so we need a plus x, okay? So we need the one that's going to give us a plus x, okay? So the one that gives us a plus x is if on the outside is a positive, okay? So it's the one that's a positive. So that's when you make the modulus sign negative. Like that. So that's just x minus a. And that makes sense because you can see it crosses at minus a, right? But the other side is a negative mod. So if I was to color code it for you guys. And then the negative one. That minus that. So that'll be a minus x minus 2a. That'll be a minus x plus 2a. Which is 3a minus x. Okay. So what x minus a, when you make that equal 0, that's a. And when you make this equal 0, you get 3a. Okay, so that's where 3a is. Cool. So now we know that when we integrate between 0 and 3a, we just need these areas. And they're all, well, actually, they're not right-angled triangles. But the first one, this one, is nice and simple. We have the base area there is, the base length there is a. And this is a. So you have a half times the base length times the height, which is a squared over 2. And then what would the area of the middle triangle be? Would you guys split it up, or is this Wojciech? How do you pronounce my name properly, Dylan? Lun. Is it just a squared? So the base length is 2a. And then the height. So here, guys, you just need the vertical height is just a. So it's half times the base length times the height. Lun gang, come on. A half of 2 goes a squared. So the total is a squared over 2 plus a squared. So 3 over 2a squared. So yeah, there you go. That's how you do that one. Encore? Encore, encore. What do you guys think? No mistakes this time. Time to sleep. Encore. Hey, yo. I think, yeah, I'm going to hang about for a few more minutes. But guys, don't forget to scan for the free resources. Yeah, so make sure you scan this. And also don't forget about the other Cram courses. Link is in the description for those. You'll get emailed if you guys want to leave a Trustpilot review for me. It will help me out a lot. So thank you for that. But hopefully this was valuable to you guys. I'd appreciate if you, before you leave, you hit the like button. Make sure you subscribe. If you do want to do any more revision, I would recommend you do go to sleep, get some food. I do have the A-level playlist for you guys to watch as much as you can. But you guys absolutely smashed it today. I respect the hustle. Hopefully this was very valuable to you. I think we've covered quite a lot of topics. I think you will be in a good position for tomorrow. Don't forget about my Cram Course 1 video, which you guys can rewatch some of the important questions. But yeah, don't forget, guys, next Wednesday is the massive Lungang 12-hour stream. We're going to survive. But hopefully you can all make it. I'm not 31 yet. But Lungang for life. Well done again, guys. Well done, well done, well done. You guys are raising the grey boundaries for yourself. Yeah, it's a 12-hour stats and mechanics stream. Guys, make sure you get a good night's sleep. Will it be 6 hours each? I guess you could say that. Average. As in, I'm going to go through a bunch of mechanics topics, then stats topics, then going through some of my personal exam questions. 12 hours. The grind never stops, man. The grind never stops. Nigel, we'll start at 9. 9 till 9. Yeah, for most of you guys, basically for all of you guys, last day of Pure. And don't watch that, guys. I'm going to be uploading some killer mechanics and stats questions over the next few days, starting from Friday. So make sure you get some rest after the exam tomorrow, because on Friday we're going to be back on the grind. Well done again, guys. Gabriel, yeah, but because we're on the area, we just made it positive. We only considered the positive side. Okay, Spiral, do I remember Claremont? I do. Long time since I was at Claremont. 6 years, man. Love for that, guys. I appreciate you. You guys killed it today. Shout out Hamza for still being in the stream. See you guys. When does the 12-hour stream start? It's going to start at 9 till 9. So yeah, guys, I'd appreciate if you hit the like button before you leave. We're nearly on 1900. Maybe we can hit 1900, but probably not, but it's all good. Everybody get a good night's sleep. Learn gang for life. I'm glad this has been valuable to you guys. Love for the support. Love to you guys. Good luck tomorrow. Bye, guys. Make sure you let me know how it goes. Make sure you let me know how it goes. Respect to you guys. You've worked very hard this year. Hey, yo, learn gang, learn gang. Thank you for the 1900 likes, guys. Love to all of you. Make sure you get a good night's sleep. You're welcome, you're welcome. When you store values into A and B, can you use those letters in your method? Yes, Jizir. As long as you label that something is A, the examiner will be able to follow. Love to you guys. I am going to head... wait, if I didn't use the correct notation for the vectors, like the line, do you lose? No, Mentos music, you'll be all right. I underlined just because it's the correct notation, but if you don't, it's all good. Fred, it'll be next Wednesday, so you guys don't want to miss it. E-Man, where's the mark scheme for the workbook? I am the mark scheme, so you can just flick through the video to the end of the question. You will see. Caviar, yeah, I'm hopping on the Jubilee line. Hopefully no delays, man. Fingers crossed. My phone is just about surviving right now, but we will see. James, it starts at 9 next week. Kemcho, Sunny. Kim, how do we generally do double chain rule? It's not like how do we do double chain rules? You identify what type of function it is, and you differentiate according to the rules that we've set. So if it's a power function, you differentiate what's inside the bracket first, then you bring down the power, knock one off the power. Yeah, I do need to go and feed my cat. Julie line, not the Lizzie line. Yeah, I don't live in West or East. I'm a burnt oak boy. I promise I'll feed my cat. She's gonna be upset. Neil, don't go to Plymouth. What's wrong with Plymouth, man? Get rid of Nightbot. One sec. Let me just pause. How do I pause Nightbot? Okay, there we go. I think Nightbot's been disabled. Yeah, guys, get some sleep now. Come Brighton, please. Maybe one day. Maybe one day. Sanjani, I'm not at home right now. So Chi-Chi, she's chilling. But I'll try get her on stream eventually. But guys, you need to go to sleep now. Yeah? Go get some sleep. Go get some food. I'll catch you all tomorrow to chat. I'll release a video on TikTok about how things went. But I'll see you all on next Wednesday. Well done today, guys. When you're in the exam, try and remain as cool as possible. Try not to discuss too much and do too much in the beginning before. You want to keep your brain fresh. Yeah, try not to work too fast in the exam. It sounds contradictory, but if you let your brain work 5 steps ahead of where you're writing, it's very easy to make silly mistakes. So be very conscious about what you're writing. That's like my best tip for you. Be conscious about everything you're writing step by step and be very present about what you're writing, okay? Don't think 5 steps ahead. It's good to make a plan, but don't be thinking 5 steps ahead as you're writing, okay? Because then you will make mistakes, okay? All right, guys. That's kind of my motivational speak, yeah? Don't be too jaldi, as Drew says. Don't be too fast. Why are you coming fast, okay? Guys, good night. Enjoy the rest of your evening. It is true, we are close to 2,000 likes. We probably won't get it, but because all of you have liked already. But yeah, I appreciate the support, guys. I'm sure you guys will be fine, okay? But you don't see me. You can't see me. Let's go. Anyway, it's so difficult to end the stream with you guys. What should we do in the morning? Don't change too much in the morning. Eat the same breakfast, same routine. Maybe do a couple of questions here and there. Maybe look at a couple of questions we did today. But definitely don't do a whole paper. Don't do anything crazy. Do I reckon Fourier analysis will come up? Thankfully not. But yeah, guys, well done today. I'm actually going to head off now because I'm crashing, okay? So good night, homies, and I will see you all tomorrow after your exam on TikTok, I guess, and you guys can let me know how it went. So good luck, good night, and well done, Loon Gang for live. See you all live on stream next Wednesday. Peace out, homies. Nice.